Picture this. You look up at the night sky, and there are no stars, no galaxies, just endless darkness. The universe hasn't exploded. It hasn't collapsed. It's still here, but it's completely dead. What happened to the light that once filled the cosmos? And could this really be how everything ends? Right now, we live in what scientists call the era of light galaxies glow. Stars burn, and the universe looks alive. But this isn't permanent. Every beam of light you see tonight, every shining galaxy, is running out of time. This story takes you billions, trillions of years into the future to see what happens when the universe's last galaxies fade away. The story of the universe is really the story of energy. From the Big Bang until now, everything has depended on light, on heat, on movement, on the burning of stars. But energy doesn't last forever. It spreads out, it cools, it fades. And that simple fact will eventually turn the bright, lively cosmos we know into something cold, dark, and empty. We tend to think of the night sky as eternal. We imagine those distant galaxies will be there forever, just out of reach. But nothing in the universe is immortal, not even galaxies. And the problem starts with something invisible, the expansion of space itself. Right now, galaxies are racing away from each other because the universe is expanding. Every second, space stretches a little more. You can think of it like dots drawn on a balloon. As the balloon inflates, each dot moves away from the others. Not because the dots themselves are moving, but because the space between them is growing. When the universe first began, this expansion slowed down over time. Then, billions of years later, something strange happened. The expansion started speeding up again. Scientists named the force behind it dark energy. We still don't know what dark energy actually is, but it's powerful, and it's making galaxies drift apart faster and faster. Over the next few trillion years, galaxies we see today will move so far away that their light will never reach us again. It will be as if they vanished from the sky, even though they're still out there, hidden beyond what we can ever see. That's the first way the cosmos loses its light. Distance. Imagine looking through a telescope and seeing fewer and fewer galaxies each century. One by one, they slip out of view as their light stretches, fading into infrared, then into wavelengths too long for our eyes or instruments to detect. Eventually, only the galaxies in our local group, like Andromeda and the Milky Way, will remain visible. Everything else will disappear into the dark. A sky with no distant galaxies, just faint smudges adrift in an endless black ocean. Our Milky Way is still forming stars, though not as fast as it used to. Billions of years ago, galaxies were bursting with newborn stars, clouds of gas colliding to create brilliant, massive suns. But over time, they ran out of that gas, the raw material for star formation. The universe's total rate of starbirth is now only a fraction of what it once was. The great factories that built stars are shutting down. When the Milky Way merges with Andromeda in about 4 billion years, that collision will trigger one last great wave of starbirth, a final fireworks show. But after that, even the combined Milkomeda galaxy will begin to dim. The gas will be used up, the lights will go out. Each galaxy becomes like a city after a power outage, a few flickering lamps in an endless dark. Red dwarfs, the smallest, longest living stars, will be the last to burn. They'll glow faintly for trillions of years, like dying embers. Most will be so dim that their light would barely cast a shadow. But they will be the final beacons of heat in a universe falling silent. The red dwarf era will last longer than all of cosmic history so far. But eventually, even those tiny suns will fade. When that happens, Galaxies will transform into graveyards, vast collections of stellar corpses, white dwarfs, neutron stars, and black holes. White dwarfs will cool from bright white to dull red to black over unimaginable timescales. Neutron stars will fade to invisibility. The only flashes of light will come when a stray comet or planet falls into a black hole and is torn apart, a spark in an eternal night. Even gravity won't last forever. Tiny interactions will fling stars and remnants into intergalactic space until galaxies dissolve into lonely wanderers. The universe will look empty, scattered islands of faint matter drifting apart as space stretches faster than ever. It's a fitting name. The cosmic winter. Cold. Still. Endless. If you stood in a galaxy then, you wouldn't recognize it. No spiral arms, no glowing gas, just blackness, punctuated by the faintest glimmers of dying stars. The Milky Way would be a ghost, its stars long gone, its remnants invisible. But the cosmos wouldn't be completely silent. Black holes would still stir, merging and sending faint gravitational waves through the dark. The universe would hum, quietly, even as its light disappeared. Everything we see today, every star, every galaxy, exists in a brief window of cosmic history. For nearly 14 billion years, the universe has been filled with light, but this era of light is temporary. Compared to the darkness ahead, it's a flicker. We are living in the bright youth of the cosmos, the only moment with enough energy and complexity for life. That makes our time miraculous. In the far future, intelligent beings might look up at a black sky, unaware that galaxies ever filled it. The evidence of the Big Bang will be gone, stretched and cooled until it fades completely. To them, the universe will seem eternal and static, its true story hidden behind darkness. The cosmos will erase its own past. As the lights go out, the universe closes its curtains one by one, leaving no trace of its brilliance. We may be the only witnesses while the stage is still lit. But maybe that's what makes this moment beautiful. It's temporary. The fleeting nature of light makes it precious. Every galaxy shining now is a heartbeat in the life of the universe. The end of light isn't tragedy, it's transformation. The cosmos isn't dying in chaos, it's settling into silence. Every star that fades is part of a rhythm older than time. Birth, brilliance, rest. Knowing that gives meaning to the now. It reminds us that our moment under the stars is rare and sacred. When we look up at the night sky, we're seeing ghosts, ancient light from worlds that may no longer exist. Those final photons will travel through space forever, redshifting into invisibility until even they are gone. And then the night will return to perfect blackness. But the universe won't be gone, only still. The atoms will drift on, quiet and cold. We are a flicker in that vast story, living in its briefest spark of brilliance. We are the children of light, born during the only time the cosmos could shine. One day, the night will win again. But for now, we get to see the universe awake. We get to watch it dream in color. The story of fading galaxies isn't about despair. It's about wonder. Everything ends, but not in ruin. It ends in peace. And maybe that's what makes the stars so moving. They shine because they know they can't forever. Right now, the sky is still full of light. And for this fleeting moment, the universe is alive. In the vast expanse of cosmic time, the universe has quietly slipped into a new and eerie stage. Long ago, galaxies thrived with brilliant stars, but those ages of light have passed. One by one, the great star cities have dimmed as their stars exhausted their fuel. Now, what remains of that bygone brilliance are only faint reminders, cosmic embers scattered in an ever-deepening darkness. Yet even in this late age, a few pinpoints of light still endure. Chief among them are white dwarfs, the faint cores left behind by once mighty stars. These stellar embers shine weakly with residual heat, no longer powered by fusion, but still aglow from their past. In countless shades of red and orange, white dwarfs speckle the darkness, like scattered coals from a long cold fire. Each one is slowly cooling over trillions of years, fading from a white-hot brilliance to a ruddy glow as the eons pass. In the extremely far future, even these embers will cool to invisibility, becoming black dwarfs, cold, lightless spheres of ash adrift in the dark. Elsewhere drift the neutron stars, the collapsed hearts of giant suns that once ended their lives in spectacular supernovae. These ultra-dense remnants are only a few miles across, yet they carry incredible gravity in a silent, smouldering form. Long ago, a newborn neutron star might have been a pulsar, spinning and flashing beams of radiation into space. Now, after eons, their spins have slowed and their light has faded, leaving them as barely detectable ghosts in the cosmic night. For all their mass and intensity, they emit almost no warmth or light, blending completely into the darkness. Lurking deeper in the darkness are the black holes, the silent endpoints of the most massive stars, and the ancient anchors of long-vanished galaxies. In this twilight cosmos, black holes are among the last great masses remaining, yet they are effectively invisible. Each one is a pocket of extreme gravity where light itself can no longer escape. Long ago, some were surrounded by swirling disks of hot gas and shone brightly as they fed on infalling matter. But now the universe offers little for them to consume. Perhaps a thin trickle of gas still spirals into a few black holes, creating a ghostly accretion glow. But as the fuel runs out, even those faint glimmers expire. They persist in quiet solitude, detectable only by the subtle tug of their gravity on the dim matter still drifting nearby. Together, white dwarfs, neutron stars, and black holes form the sparse, glittering remains of a once radiant universe. Scattered across unimaginable distances, they seldom encounter one another, and none can replenish the light that has been lost. Each is a monument to a star that lived and died, a final echo of light or gravity persisting into the cosmic night. They are the last waypoints of matter that still shine or influence space in any noticeable way. For now, they merely endure as silent guardians, while the darkness deepens around them, keeping vigil over a cosmos that grows quieter with each passing eon. Like lonely lanterns spaced across a limitless night, they continue their vigil as the cosmic night deepens. For a traveller drifting through a galaxy in this epoch, the view would be unlike anything we know. The sky that was once rich with sparkling stars would be almost completely black. Perhaps only a handful of faint red glows from distant white dwarfs or aging red stars would prick the void. The plane where the galaxy's stars once clustered would be an almost invisible haze, detectable only by the faint absence of background light. Where once a bright Milky Way band arched across the sky, now there is only an emptiness, a gentle suggestion of structure in the pattern of darkness, if one knows where to look. No colourful nebulae or globular clusters mark the galactic core. Even the galaxy's center has become a barely discernible blot of night within night. In every direction, darkness dominates, broken only by those rare weak points of light that hint at the brilliant era long past. Yet even in this near-silent era, a slow and subtle dance continues. Gravity, the same force that once gathered stars into galaxies, still tugs at these lingering objects. Over incomprehensible spans of time, it draws some together or flings others apart, orchestrating final encounters among the cosmos's elder remnants. In the grand scheme of ages, nothing stands completely still. Even in the great cosmic silence, gravity continues its subtle work, ensuring that nothing truly stands frozen forever. On the rarest of occasions, perhaps once in many billions of years, the darkness is pierced by a final flash of starlight. If two white dwarfs happen to spiral into each other, their merger can ignite a runaway thermonuclear fire. In an instant, what was once a pair of faint embers erupts into a brilliant supernova, flooding the void with the radiance of billions of suns. For a few brief weeks, night is banished by this blaze before it fades away, leaving behind only expanding clouds of ash. The debris of such an explosion, enriched with heavy elements forged in the blast, billows outward into space. But with no new stars to gather it, those ashes will simply drift forever in the darkness. In this late epoch, such a spectacle might occur only once in tens of billions of years, a solitary firework in an eternity of night. For an observer in that far future, the sudden blaze of a supernova would be almost unimaginable. A lone, blinding beacon erupting in a sky that had been dark for ages. For a brief moment, the heavens would come alive again, illuminated as in ancient times, only to fall silent once more when the outburst faded. The memory of that burst of brilliance would linger in the eternal night, a poignant reminder of the fireworks the universe once knew. Even more powerful is the collision of two neutron stars after ages spent slowly spiraling together. When they finally crash, they unleash a torrent of energy and forge precious elements like gold and platinum in one blinding flash. Space itself shudders from the impact, a ripple of gravitational waves racing outward, while an intense burst of multicolored light briefly ignites the darkness. In the aftermath, the two shattered stars collapse into a single black hole, sending one last invisible tremor through the void. Just like that, the brilliance is gone, and the universe returns to quiet darkness. Events like this are exceedingly uncommon, likely among the final grand fireworks the cosmos will ever witness. Not every merger ends in catastrophe. In fact, some collisions give birth to new light instead of destruction. If two white dwarfs combine with less than a critical mass, they avoid the fate of a supernova and instead fuse into a single new star. The merged remnant can briefly spark fresh nuclear fires, perhaps burning leftover helium or carbon, and shine anew for a short time. For a moment in cosmic terms, this resurrected star may burn hotter and bluer than it ever did in life. A phoenix rising from stellar ashes. Such a star might live only millions or a few 100 million years, a mere flicker by cosmic standards. But in the darkness of this era, even that is a noteworthy rebirth of light. Even failed stars can join forces to shine. Two brown dwarfs drifting in the dark might eventually come together. Alone, each lacked the mass to ignite fusion, but together their combined heft can push them over the threshold. The result is the birth of a tiny red dwarf, where once there was none, a new star flickering to life in the cosmic night. It glows dimly, a dull red orb, but it could burn for trillions of years, serving as one of the last steady beacons in an ever-darkening universe. Such occurrences are extraordinarily rare, yet given enough time, gravity can tease out one final spark of starlight. Even in this twilight of the cosmos, such second-chance stars are like small miracles in the dark. They show that the universe has not entirely lost its creative spark. Now and then, it manages to kindle a tiny new flame from the ashes of the old. These instances are few and far between, brief candles flickering to life in an ocean of night. But they offer a last echo of the cosmos's former brilliance, a final gesture of creation before the long darkness. Over even longer timescales, gravity quietly reshuffles the cosmic stage. The stellar corpses nudge and tug on one another in repeated encounters, gradually altering their courses. Through countless gentle perturbations, lighter remnants pick up speed and are flung outward, eventually escaping their home galaxy and setting off into the intergalactic void. Meanwhile, the heavier objects lose momentum and sink toward the galactic center, spiraling slowly into the supermassive black hole at the core. It is as though the galactic dance hall is emptying out. One by one, the stellar dancers are cast into the night, leaving behind an ever more desolate ballroom. Eon by eon, this process empties out the galaxy's graveyard. Nearly all stars and remnants are either thrown into endless exile or devoured by the central black hole. In the end, the once great galaxy is reduced to a shadow of its former self. Perhaps only a dark central mass, and a few straggling companions remain in what was a bustling metropolis of stars. It is the sunset of the galaxies themselves. A galaxy that once shimmered with hundreds of billions of stars is now a ghost of its former self. In the end, it holds perhaps only a few dozen faint embers and a massive black hole, where spiral arms and bright nebula used to be. The grand cities of stars have emptied out, leaving just a sparse outline, a memory of a galaxy fading quietly into the night. Yet even without visible stars, something of the galaxy remains. An invisible halo of dark matter still envelops the galactic remnant, holding it together with gravity. This dark matter has always been unseen, but now it is virtually the only structure left, a ghostly scaffold preserving the faint outline of what once was a galaxy. In this way, gravity's slow choreography draws the final curtain on the age of stars. What remains is a sparse scene, a massive black hole brooding at the center, and a few faint stellar corpses orbiting nearby, while most others have been flung far afield. The cosmic dance floor is nearly empty now, save for a few stubborn lights that have not yet gone out. Among those, the most enduring are the smallest stars of all, the red dwarfs, still flickering softly as the darkness deepens. Even at this late stage, these diminutive red suns are the final true stars to cast their glow across the universe. Among the universe's remaining lights, the red dwarf stars are the ultimate survivors. These diminutive stars are the smallest and coolest of the stellar family, glowing with a gentle ruby hue. A typical red dwarf holds only a fraction of the sun's mass, shining with just a tiny sliver of the sun's brightness. Yet what they lack in brilliance, they make up for in endurance and efficiency. In fact, red dwarfs have always vastly outnumbered their larger cousins, unnoticed workhorses amid the glare of bigger suns. Once easy to overlook during the universe's heyday, in the fading cosmos, their steady glow becomes the primary source of starlight. Red dwarfs live life in the slow lane. None has yet died in the current universe, simply because 13 or 14 billion years is nothing compared to their immense lifespans. These stars burn their hydrogen so sparingly that they can endure for trillions upon trillions of years. Their cores are fully convective, constantly churning and using every bit of fuel, which means no part of the star ever goes unfueled. To put it in perspective, a star like our Sun might shine for 10 billion years, but a small red dwarf can last 1,000 times longer or more. As larger stars one by one wink out, the tenacious red dwarfs continue to shine steadily, becoming the dominant sources of light in an ever-dimming cosmos. All of human history, and even the entire existence of our Sun, would not even register as a moment in these trillion-year spans. One can imagine, for instance, a tiny red dwarf born in our galaxy's youth, while larger stars blazed and died in the brief span of millions or billions of years. This little star would burn steadily on. It could survive through the Milky Way's merger with Andromeda and remain shining when all other suns have perished. Only after trillions of years more, in the farthest future, would this resilient ember finally exhaust its fuel and quietly wink out. In the deep future, a sky lit by a red dwarf would be a quiet, dim twilight. A planet circling such a star would know no bright daytime, only a perpetual dusk, a faint coppery glow cast by its tiny sun. At noon, the illumination might resemble our own sunset, bathing everything in a ruddy light. The night, by contrast, would be darker than any night we can imagine today, with most other stars long gone or too weak to see. If any life or late observers were there to look up, they would behold a nearly empty heavens, their own feeble red sun one of the last beacons against an all-encompassing dark. Around these small, steadfast stars, the dwindling warmth and light could nurture the universe's final flickers of life and hope, huddled close to the last campfires of creation. Yet even the red dwarfs cannot burn forever. After trillions upon trillions of years, each one will finally consume the last of its hydrogen fuel. When that quiet moment comes, there is no dramatic explosion or brilliant finale, only a gentle fading into darkness. The star's core contracts and heats for a short time as fusion sputters out, but it lacks the mass to ignite any new kind of fire. Instead, the red dwarf slowly transforms into a dense, helium-white dwarf, essentially the glowing cinder of a star. Over further eons, it will cool and dim into invisibility, becoming a black dwarf, a cold, lightless sphere marking where a star once shone. At that point, it would be practically undetectable, a black dwarf radiating just a whisper of heat, drifting through eternity as an invisible relic. In an unimaginable future, there will come a moment when the very last star in the universe flickers and dies. Perhaps it will be a lone red dwarf in a quiet corner of a now empty galaxy, sputtering out its final breaths of light. When that happens, the cosmos will witness something it never has before, a night with no stars at all. For the first time since stars began to shine, not a single point of starlight will remain in the sky. The end of the age of starlight will arrive quietly, without fanfare. A silent, profound turning point. There will likely be no eyes to see it, and no minds to mourn it. This final sunset of creation will pass in absolute solitude. In that moment, a long chapter of cosmic history closes, and an even deeper darkness descends across existence. There is a solemn grandeur in this slow dimming of creation, a bittersweet calm as the cosmic lights go out one by one. This final extinction is as momentous in its way as the ignition of the first star. But unlike the triumphant dawn of light eons ago, this event arrives softly, marked not by brilliance, but by the cessation of it. The cosmic theatre falls dark, not with a thunderous clap, but with a gentle sigh of conclusion. An age that began in brightness ends in stillness. Still, even after the last star has gone dark, the story of cosmic matter is not complete. Not everything in the universe disappears with the starlight. Around those long-dead suns, planets and moons remain, drifting through space with no star to warm or guide them. These are the cosmic orphans, worlds once bathed in sunlight, now cast into cold eternal night. Even the dust, asteroids, and comets of ancient solar systems still wander, unseen and alone, carrying on in the darkness. Many planets remain bound to the remnants of their parent stars, long after the light has died. A world that once basked in daylight may continue to orbit a white dwarf ember, or even a silent black hole. By now, its days and nights are almost indistinguishable, lit only by the faintest glow of its shrunken sun, or by nothing at all. An Earth-like planet in such conditions would freeze beneath an endless night, its oceans turn to ice, and its atmosphere fallen as frost on the ground. Yet it keeps circling out of ancient habit, a loyal companion to a star that no longer shines. Someday in the far future, our own sun will be one such dark remnant, and any surviving planets, perhaps a frigid, lifeless Earth, will likewise orbit the sun's corpse in silent darkness. For a moment, imagine standing on the surface of one of these orphaned worlds. Above you, the sky is a pitch-black void. No sun rises or sets to mark the passage of time. The only hint of illumination might be a faint, ghostly glow from a distant galaxy's remnants, or the feeble shine of a far-off cluster of stars, scarcely enough to cast a shadow. The landscape around you lies in a dim, starlit gloom and eternal frost. Any air that once existed has long since condensed and fallen, coating the ground in a thin layer of frozen atmosphere. What were once oceans are now solid plains of ice, stretching into darkness. In that silence, you would hear nothing but your own movements, perhaps the crunch of frozen ground beneath your feet, or the faint sound of your own breathing inside a suit. There is no wind, no rustling of leaves or stirring of water. It is a world absolutely at rest, waiting in vain for a dawn that will never arrive. Other worlds find themselves completely untethered, flung out of their ancestral systems into the great void between the stars. These rogue planets drift alone, with no sun to call their own, eternal travellers under a starless sky. On such a world, night is unbroken and absolute. Years and seasons lose all meaning without a sunrise or sunset. Its only warmth might come from a fading core, or the slow decay of radioactive elements deep below its surface. Perhaps a particularly massive rogue planet, like a solitary Jupiter, could glow faintly in infrared from residual heat, appearing as a barely perceptible reddish dot if one could see it up close. But even that feeble glow will ebb over eons, and the planet will become just another cold, wandering sphere. It may roam for billions upon billions of years without ever nearing another celestial body, destined to remain alone in the dark. In fact, astronomers today have found hints of such nomadic worlds in our own galaxy, rogue planets adrift without a star, offering a small preview of the isolation that will one day dominate the cosmos. Over incomprehensible spans, a few of these orphaned worlds may yet meet a final fate, a planet still bound to a white dwarf or black hole could, through the gradual ebb of orbital energy, spiral inward, inch by inch. After trillions of silent revolutions, it might eventually plunge into its cold sun, releasing a last whisper of energy as it is swallowed. When a lone planet finally falls into a black hole, it would be torn apart. Its material would form a brief, hot disk of infalling matter, producing one final flare of X-rays and light before vanishing into the darkness. A rogue planet drifting in emptiness might, by the slimmest chance, someday encounter another wanderer. It could collide with a fellow drifter, their impact unleashing a momentary burst of heat and light. Two frozen worlds briefly igniting as they smash together in the dark. Or perhaps a lone planet might be captured into the orbit of a massive remnant, becoming a distant moon of a black hole or neutron star. But such encounters are exceedingly rare in the vastness of space. Epochs upon epochs could pass without a single one. For the vast majority of orphaned worlds, no dramatic finale awaits. They will simply continue their silent journey through an endless night, perhaps until the end of time itself. In a sense, these orphaned worlds and stray fragments are the final keepers of the universe's history. Each frozen planet and wandering rock is a silent relic of a time when things were warmer and brighter. They drift through the void as if bearing witness to all that has come before. A time when galaxies swarmed with stars and life and energy. Now they remain as lonely memorials, carrying the story of their long-vanished suns across the emptiness. Not only planets, but also smaller castaways now populate the dark. Frozen comets, asteroids, brown dwarfs, and the shattered debris of long-vanished worlds. They drift aimlessly, just as the orphan planets do, each piece a remnant of a bygone solar system. There are no new forces to gather them, no sunlight to warm them. They remain simply rubble in a limitless void. In this graveyard of worlds, everything moves in nearly perfect silence. All the fires that once lit the universe have been extinguished, leaving only cold relics and a deepening cosmic quiet. In this final twilight, a strange peace falls over the cosmos, as though it has exhaled after ages of restless creation. With the last star extinguished, the cosmos has entered a fundamentally new phase of its existence. No new stars will ever be born in this darkness. The raw material for star-making, cold hydrogen gas and dust, has been used up or locked away in low-energy forms like degenerate stellar remnants. What little gas remains is far too thin and dispersed, stretched by eons of expansion to clump and ignite new fires. Driven by the relentless push of dark energy, this expansion has thinned out the cosmic gas even further. The great cycle of stellar birth and death, which once filled the universe with light, has ground to a halt. From this point on, the cosmos produces no new light. It only spends the dwindling energy remaining from its brighter days. For billions of years, the cosmos was a busy workshop, forging stars and planets. Now, the tools lie idle. Great molecular clouds that once blazed with newborn suns are dark and dormant. The stellar factories have shut down, and the lights in the workshop of creation have flickered off. The universe, once a ceaseless engine of creation, has entered retirement. As time marches on, the universe continues to expand and cool, pushing the remaining matter ever farther apart. Galaxies that once clustered together have long since merged or drifted hopelessly apart under the accelerating swell of space. By now, the cosmos is essentially empty on the grandest scales. Each surviving clump of matter, be it a lone star remnant or a solitary black hole, exists in growing isolation. Long ago, Distant galaxies faded from sight as their light was stretched beyond all detection, leaving only the local group of remnants in each region. Now, even within those local groups, distances widen and interactions dwindle to near nothing. Every remaining object becomes an island of existence, marooned in an ever-expanding sea of night. The darkness between them grows, and the silence deepens with every passing epoch. There are no familiar constellations, no glowing band of Milky Way, no distant galaxies visible at all, nothing but blackness in every direction. If one could travel through space in this epoch, one might drift for millions of light years without encountering a single star. The universe has become a vast expanse of nearly starless void, punctuated by the occasional island of matter. Where once every patch of sky was filled with galaxies and star clusters, now an unfathomable emptiness separates the remaining lights. Each pocket of the universe is now surrounded by a horizon beyond which nothing can ever be seen or felt again. Distant regions have slipped over this cosmic horizon, receding faster than light can follow. Every island of matter is truly alone in space-time, forever out of reach of any other. Any traveller would move through a true wilderness of dark, with only the faint pull of gravity to hint at structures far away. The mightiest remaining objects are the black holes that lurk in the darkness. Supermassive black holes sit in the hearts of dead galaxies, including the hushed remnant of our Milky Way, and smaller black holes wander wherever massive stars once exploded. Yet even these exotic giants provide no light now. Without infalling gas or stars to consume, they are essentially quiescent, immense masses of silence. Only a whisper of energy escapes them through slow quantum decay, a phenomenon known as Hawking radiation, an almost undetectable trickle of heat. This means that even black holes are not truly eternal. In incomprehensibly distant times, they too will evaporate and fade away. For now, though, they simply persist as the last massive sentinels of a once bright universe, dark monarchs of an empty cosmos. The timescale for this decay is almost incomprehensible. Even a black hole with the mass of a star would take around 10 to the 67th power years to evaporate, a number with over 60 zeros. The supermassive black holes in galactic cores would endure far longer still, outlasting any other structure by an absurd margin. To any conceivable observer, these giants would seem practically eternal, changing only on timescales far beyond an already far future universe. In the absence of new energy sources, the cosmos falls toward a final equilibrium. The faint afterglow of the Big Bang, once a warm, diffuse radiance filling space, has now stretched and cooled to near nothingness. Even the light from all those long-ago stars still quietly traverses space, but it too has faded to obscurity. Photons that once illuminated galaxies have been stretched to harmless, invisible wavelengths by the ever-growing cosmos. The brilliance of the past is not gone entirely. It has become a thin, cold whisper of radiation, a ghost of the radiance that was. It streams onward through the void, unnoticed and impotent, carrying the memory of a brighter universe into eternity. The background temperature of the universe creeps ever closer to absolute zero. With no starlight or fresh energy input, all remaining matter and radiation move toward a state of uniform, cold stillness. In practical terms, no differences remain, no warm spots or cool spots, no concentrated sources of energy from which to draw work. It is the so-called heat death of the universe, not a fiery apocalypse, but a slow fade into perfect darkness and maximum entropy. This is a cosmic winter, with no spring to follow. An endless night, where change comes only on the slowest, subtlest scales. In this final state, the universe is as inert as a still ocean under a starless night. Everything is almost perfectly uniform. No currents of energy flow from one place to another. It is a silent, static cosmos, nearly the same everywhere, with no bright spots or shadows left, just an endless expanse of near-nothingness. The drama of cosmic evolution has given way to a calm that borders on absolute stillness. At these timescales, even the concept of time begins to lose its meaning. When nothing much changes for 1 billion or 1 trillion years, the difference between a moment and an epoch blurs. If there were an observer now, they would see so little happen that years and millennia would slip by unnoticed. The universe's clock ticks ever slower in this great hush, and events that once unfolded in a heartbeat of cosmic time now stretch out, seemingly forever. The cosmos has become a vast, quiet expanse, dotted only with invisible remnants and the faint pull of gravity. It might seem that all grand events have now ceased, yet the story is not quite over. In the eons ahead, even black holes will meet their ends, and even matter itself may decay into a drizzle of faint radiation. For now, the universe rests in this profound stillness, a silence that will only deepen as the last remaining traces of structure slowly fade away. It is like a long winter's night, with no dawn on the horizon, the final hush before the universe's next, and perhaps ultimate, transformation. In this profound darkness, the cosmos rests in a long twilight. The great stellar cities, the galaxies, have gone dark, their once bright lights extinguished. The age of blazing suns has come to a close, leaving behind a hushed expanse with only echoes of starlight. Yet scattered across this black canvas are a few tiny beacons, the last glowing embers of creation. The background glow that once filled the universe has long since dissipated. In ages past, even the emptiness of space was alive with a faint warmth from the Big Bang's afterglow. Now, eons of expansion have stretched that light into oblivion, and the temperature of space has drifted ever closer to absolute zero. The darkness between stars is truly dark now, an almost perfect silence of light and energy. Over the eons, the relentless expansion of space has also pulled the galaxies apart into isolation. Once, the night was adorned with the hazy shimmer of distant galaxies and the dense river of starlight called the Milky Way. Now, those distant galaxies have slipped beyond sight, and even the Milky Way's familiar band has faded from view. Each surviving island of stars is marooned in darkness, with no neighbouring galaxy visible in the sky, each alone in a vast sea of night. Somewhere in the void drifts a white dwarf, the smouldering core of a star that once shone like our sun. Now that star's outer brilliance is gone, shed into space long ago, and all that remains is this dense ember, no larger than Earth yet, weighing as much as a star. It glows with a pearly white light at first, a final gift of heat left over from its vanished youth. But as eons slip by, even this brightness will fade, cooling from white to red, and eventually to nothing at all. So patient is the cooling of a white dwarf that the universe has not yet seen any turn completely dark. These cosmic embers will take trillions upon trillions of years to cool into black dwarfs, lightless spheres of degenerate matter. In this far future epoch, though, time is abundant. Years and centuries mean little now. Even millennia are mere moments on the cosmic clock. The white dwarf we encounter still carries a gentle glow, illuminating nothing but the emptiness around it as it slowly surrenders its remaining heat. Deep inside such a white dwarf, exotic changes take place as it ages. Its hot, dense core begins to crystallize like an immense cosmic diamond. Astronomers in earlier times predicted that old white dwarfs would become giant gems of crystallized carbon and oxygen. In this far future, that process is well underway, slowly turning what was once a star's heart into solid crystal. It is a transformation as silent and slow as the cooling of the universe itself. In a real sense, the white dwarf is becoming an enormous cosmic diamond, an immense gem glowing faintly in the darkness. Even our sun, long ago, became such a white dwarf. In the distant future of our own solar system, the sun's remains would be a faint, cooling sphere orbited by the frozen relics of its planets. In this twilight cosmos, countless suns have met the same fate. Each white dwarf drifting now is a memorial to a star that once warmed worlds and lit the sky, now reduced to a small, glowing core in the dark. For other stars that burned more fiercely, the remnant left behind is even stranger. Not far away, a neutron star circles in the dark, the collapsed husk of a once massive sun. It is a sphere only a few miles across, yet heavier than a star, an unimaginably dense ball of neutrons. A mere spoonful of this object would outweigh the tallest mountain. Long ago it might have spun as a pulsar, shooting beams of energy into space, but now it is still and lightless, radiating hardly any warmth into the infinite night. At the surface of this neutron star, conditions remain extreme and alien. A faint atmosphere of exotic particles clings to it under gravity billions of times stronger than Earth's. Any ray of light that still tries to escape its surface would be bent and reddened by the star's intense gravity. The neutron star also carries a magnetic field of immense strength, though over the eons it has weakened from its initial fury. Now, in these old and quiet times, this dense stellar corpse rests with hardly a flicker, a cosmic cinder holding only the memory of its star's once brilliant fire. In contrast to these stellar remnants that still cling to leftover warmth, there are others that give off no light at all. Drifting silently through the void is a black hole, the final fate of the most massive stars. It is invisible to the eye, a well of gravity where a star collapsed into endless darkness. Around this silent abyss, space itself is warped and time stretched. Yet from afar, it blends seamlessly into the starless backdrop. If a stray object wanders too close, it might briefly flare as it is swallowed. But otherwise the black hole reveals itself only by the gentle tug it exerts on what lingers nearby. Some black holes wander alone, born from single giant stars that died in isolation. Others lurk at the centers of ancient, silent galaxies. These supermassive black holes, millions or billions of times the mass of the Sun, still mark the hearts of their former galactic homes. In the current darkness, even they are nearly undetectable unless they gorge on some last stray mass and release a final burst of energy. Such feasts are exceedingly rare now. For the most part, even these giants simply persist in quietude. Drifting among these ghosts of stars are also the failed stars known as brown dwarfs. These objects were never massive enough to ignite a true stellar fire in their cores. They spent their lives as warm, dim globes, glowing gently in deep red or infrared light. By now, even that heat has largely ebbed away, and many brown dwarfs have cooled to resemble faint, Jupiter-like planets. Though they never blazed brightly, they are numerous, and they endure as silent, brownish orbs floating through the darkness, as unobtrusive as shadows. All these remnants, white dwarfs, neutron stars, brown dwarfs, and black holes, are the last visible matter in existence. In time, even these embers will wink out, leaving behind only cold, black dwarf stars, silent neutron cores, and the unseen gravity of black holes. Scattered among them, the occasional brown dwarf will drift like a cooling cinder, emitting barely a whisper of warmth. For the moment, though, these remnants are still the faintest of beacons, the final markers of a universe that once brimmed with light. Across the cosmic emptiness, they dot the darkness like the last glowing coals of a once roaring fire, slowly fading, but not yet entirely cold. Yet even in this quiet darkness, the pull of gravity persists. None of these objects floats in perfect isolation forever. Over tremendous spans of time, they continue to tug at one another, drawing together or flinging apart in a slow, ghostly dance. The light may be gone, but the cosmic ballet carries on, setting the stage for new, subtle changes to come. Gravity, though unseen, continues to choreograph the movements of everything that remains. In the darkness, every white dwarf, neutron star, and black hole still feels a subtle pull from others drifting in its vicinity. Over the course of eons, these gentle tugs add up, altering paths and drawing some objects into slow, spiraling dances. The cosmos may be quiet and nearly empty, but it is not static. An invisible ballet of matter carries on, step by step, under gravity's enduring direction. In the scant remains of galaxies, encounters between wandering objects still occur from time to time. Two white dwarfs might drift near each other, or a neutron star may pass by a black hole, and their gravitational fields interact. When three or more bodies come together in such a close pass, the result can be unpredictable. It is akin to dancers meeting on a sparsely populated floor. Two might end up paired together more tightly, while a third is flung out of the dance entirely, cast off into the great solitude. Often, one of the lighter objects will receive a gravitational kick, enough energy to send it sailing away into intergalactic space, no longer bound to its original group. As time goes on, this process slowly empties whatever is left of the galaxy. The lighter remnants, brown dwarfs, small white dwarfs, even lone planets, tend to be flung outward and lost to the void. Meanwhile, the heaviest objects, like massive black holes or large neutron stars, sink gradually towards the center. This segregation by mass means that over billions of years, a core of heavy relics forms in the heart of a galaxy, while the lighter ones drift into the great darkness between galaxies. Even planets, which might have survived the violent deaths of their stars, are subject to these gradual perturbations. A world orbiting a white dwarf or neutron star could, over an immense timescale, see its orbit slowly decay due to gravitational radiation. Alternatively, a close encounter with another passing object could fling the planet entirely away from its tiny sun. In the end, very few orbits remain eternal. Eventually, gravity rearranges even these smaller pieces of the cosmos. In the heart of a long, quiet galaxy, a kind of final arrangement takes shape. A supermassive black hole may still dominate the center, now orbited only by a sparse retinue of dead stars. One by one, even those will likely spiral inward or be ejected, as gravity continues to redistribute energy among them. In the far future, many galaxies will end up with most of their remaining mass swallowed by central black holes, while the rest is scattered abroad. Not all remnants simply drift past each other. Some become bound together in pairs or small groups. There are binary white dwarfs gently circling one another, and binary black holes locked in mutual orbits from the earlier merging of galaxies. These pairs are slowly losing energy over time. As they orbit, they emit faint gravitational waves, tiny ripples in the fabric of spacetime that carry away orbital energy. Bit by bit, this causes the two objects to draw closer. They send powerful ripples through spacetime, gravitational waves that race outward at light speed. If some observer could somehow sense it, space would momentarily reverberate like a struck drum, a deep but fleeting tremor in the cosmic silence. For millions and billions of years, such binary partners whirl around each other in the dark. To an outside observer, they would appear almost motionless, moving in slow motion compared to the lively orbits of the past. But inexorably, their dance tightens. After an unimaginable span, perhaps longer than the current age of the universe many times over, two orbiting stellar remnants may finally come together. When they do, it can unleash one final burst of energy into the quiet night. For example, imagine two white dwarfs that have been orbiting each other for all those eons. Eventually, they merge into one. In that instant, if their combined mass is great enough, the merger can ignite a catastrophic reaction. The two small dead stars suddenly detonate in a supernova explosion, a brief, brilliant flare of light and energy. For perhaps a few weeks, a supernova like this could outshine an entire galaxy, piercing the darkness with a sudden blaze. Such a spectacle in the far future universe would be awe-inspiring, yet lonely. The supernova's flash would illuminate the surrounding emptiness, revealing ghostly silhouettes of any nearby debris for a short time. But there are few, if any, eyes to watch this final firework. After its light fades, the darkness closes in again, a bit of ash from the explosion dispersing into space where once two white dwarfs quietly orbited. After the explosion, its remnants of gas and dust, enriched with heavy elements, billow outward into space. In a younger universe, such cast-off material might have cooled and coalesced into new suns. But at this late epoch, space is too empty, and the ejected matter too thinly spread for any new star to take shape. The supernova's bounty simply dissipates, mixing into the darkness without triggering a new spark of starlight. In another corner of the universe, two neutron stars might spiral together in their own slow waltz. When these ultra-dense objects finally collide, the impact is fierce. They may collapse into a new black hole in an instant, releasing a burst of gamma rays and sending gravitational waves rolling through the fabric of space. In the process, some neutron star matter is flung outward and glows in a fading halo, forging perhaps the final new elements the cosmos will ever know. For a fleeting moment, a powerful flash of high-energy light erupts, one of the last gamma-ray bursts in a dying universe. Even black holes, the darkest of all objects, can partake in this dance. If two black holes have been orbiting each other since their host galaxies merged, they too will draw together over time. When they finally coalesce, no light is produced. Black holes merging are silent in terms of light, but they release a tremendous ripple of gravitational energy. They send powerful ripples through space-time, gravitational waves that race outward at light speed. If some observer could sense it, space would momentarily reverberate like a deep bell ringing in the darkness. Space itself rings briefly with their merger. In the emptiness, this goes unnoticed by anything but the cosmos itself, as two become one, and the number of massive bodies in the universe dwindles further. Gravity also finds ways to spark new, faint lights from time to time. In the vast darkness, two cold brown dwarfs, failed stars, might slowly drift into a collision. If their combined mass is sufficient, they could form a new small star. For the first time, the merged brown dwarfs would ignite into a red dwarf star, shining weakly but steadily. Such occurrences are exceedingly rare. Across an entire galaxy, perhaps only a few dozen new stars will ever form this way for the rest of time. Those few that do ignite will shine as tiny beacons in the dark. Even so, in this late era, they provide a brief extension of starlight, a small reprieve in the fading night. Perhaps as a result of such an unlikely merger, a long frozen world could find itself greeted by a new dawn. If a lone planet had been orbiting one of those brown dwarfs, it would suddenly have a real sun in its sky. Under the dim red glow of the newborn star, that planet's frozen surface would feel a touch of warmth, a faint, brief spring after an eternity of darkness. This small sunrise would not last forever. Even that red dwarf will eventually burn out. But for a while, in one tiny corner of the universe, day would break again. Across the universe, these mergers and collisions are spaced out over unfathomable distances and times. Perhaps millions of years separate one event from another in any given region. The long quiet of the cosmos is punctuated only occasionally by these fireworks. And as time advances, even these events become more scarce. The fuel for such moments, pairs of remnants in just the right configuration, is gradually used up. With each collision or merger, the cosmic population dwindles. Two objects become one, or an object is destroyed in an explosion, leaving behind a single remnant in place of two. Galaxies that once held billions of shining stars now contain only a tiny fraction of that number as dark remnants, a fraction that grows smaller with each such merger. Bit by bit, the variety of the cosmos simplifies. Where once there might have been a binary star system, now there is one heavier star, or a black hole. Where once two white dwarfs shone faintly, now there may be just expanding debris, or a single more massive dwarf. The trend is toward consolidation and loss, a slow settling into a quieter, simpler state. In the extremely distant future, after countless tiny interactions, most of what remains will either have escaped or merged. A lone, supermassive black hole might sit at the center of a dark galaxy, having swallowed many of the stellar corpses around it. Scattered former companions will roam the intergalactic night, or perhaps orbit far out until they are eventually ejected as well. The gravitational dance grows ever more languid as fewer partners remain to move. Yet, we should remember that the universe did not plunge into darkness all at once. The smallest stars, the red dwarfs, continued to burn far longer than their larger kin, extending the cosmic twilight for trillions of years. Before the night became truly deep, their faint glow was the last to linger. Now, we turn to these resilient red suns to see the final sparks of starlight they offered in a dimming cosmos. In the cosmic evening that followed the bright ages of the past, a soft red glow still lingered in the darkness. Scattered across space were uncountable red dwarf stars, the smallest of the stellar family, each shining with a subdued, reddish light. These diminutive suns were dim compared to stars like our sun, but they endured when all others had burned out. In this late era, they became the final keepers of starlight, dotting the universe with a faint glimmer long after bigger stars were gone. Red dwarfs are the most common stars even in our present universe. For example, the closest star to our Sun, Proxima Centauri, is a red dwarf, so faint that it cannot be seen without a telescope. They are typically only a fraction of the Sun's mass and size, often only as large as the planet Jupiter, yet dozens of times heavier. Their surface temperatures are relatively cool, giving them a reddish or orange glow. What they lack in brightness, they make up for in longevity. These stars burn their fuel so slowly that they can shine for trillions of years. Unlike massive stars that live fast and die young, a red dwarf sips at its hydrogen fuel. It is fully convective, meaning fresh fuel constantly cycles into its core so that nothing is wasted. Because of this efficient use of fuel, a red dwarf can consume nearly all of its hydrogen over a very long lifetime. A star like this might continue burning for 10 trillion years or more, outliving galaxies and cosmic structures that formed around it. For eons, while giant stars exploded and medium-sized stars faded away, the red dwarfs simply carried on. In galaxies that were gradually growing darker, they provided a last bit of light. Imagine a view from a planet in those times. The night sky would be nearly black, with only a few faint red points where once there were countless bright stars. The Milky Way's majestic band would have long since vanished. In its place, a sparse sprinkle of dull red embers across the vault of night. By that time, even the faint afterglow of the Big Bang had faded to nearly nothing. The universe's background temperature hovered just above absolute zero. Against such a black backdrop, the glimmer of those red stars, however dim, was prominent and precious, virtually the only source of warmth left in the cosmos. During this period, star formation itself had slowed to a virtual stop. The great molecular clouds that once birthed new stars were used up or dispersed. Almost no new stars were coming to replace those that died. The cosmos was living off its savings, so to speak, shining on with the remaining stars it already had, especially the hardy red dwarfs. As the trillions of years passed, even the red dwarfs began to age. The more massive ones among them, still far smaller than the Sun, exhausted their fuel first, sometimes after only tens or hundreds of billions of years, and they faded into white dwarfs. The smallest red dwarfs, however, kept on burning steadily. With each passing eon, the average light in the universe grew dimmer, confined to these few remaining faint stars. When a red dwarf neared the end of its lifespan, it underwent changes unlike those of larger stars. Instead of swelling into a red giant, a red dwarf grows gradually hotter and slightly smaller. As it uses up the last of its hydrogen, its colour shifts from red toward blue-white, a phase astronomers have theorized as the blue dwarf stage. The star becomes a bit more luminous for a time, shining with a whitish hue as it burns its final reserves of fuel. After this brief intensification, the red dwarf, now more of a small blue-white star, finally exhausts its remaining fuel. There is no dramatic supernova or explosive goodbye. Nuclear fusion in its core simply sputters out. The star's core, full of helium ash, begins to contract and cool. In time, it will settle down as a white dwarf, a hot but fading ember destined to slowly dim over trillions more years. One by one, the red dwarfs across the universe winked out in this manner. The larger ones went first. Then, progressively, smaller and smaller stars continued to shine, while their bigger kin disappeared. Trillions of years rolled by. Eventually, only a handful of the tiniest red dwarfs remained, scattered in the darkness like the last sparks of a dying fire. At last, there comes a time when a single star is the sole remaining beacon of fusion in the cosmos. The final living star might be a red dwarf of extremely low mass, just barely heavy enough to sustain nuclear burning. It has outlived all its brethren. One can imagine this last star in its solitude, a lonely crimson orb shining in a limitless night, unaware that it is the final of its kind. If any planets still circled this last star, they would witness a melancholy spectacle as the star used up its final bit of fuel and shifted from red to a ghostly blue-white. The light on those worlds would slowly dim. Eventually, the star would simply cease to shine. For any hypothetical life or observer on such a planet, however unlikely their existence might be, that final sunset would give way to an eternal night, never again broken by a rising sun. In its final phase, this last star undergoes the same subtle transformation as its predecessors. It likely becomes a small, pale blue star as it uses up the very last of its fuel, shining perhaps a bit more brightly for a short while. Then, quietly and without fanfare, fusion in that star's heart comes to a stop. The last star's fire flickers out. When that moment arrives, the age of starlight officially ends. For the first time in perhaps 100 trillion years, no star shines anywhere in the universe. A grand chapter of cosmic history closes in the most silent way imaginable. Not with a bang, but with the gentle fading of the final light. The deep night that follows is darker than ever before, and truly profound in its stillness. All that remains illuminated now are the ghosts of stars, the white dwarf embers, cooling neutron stars, and perhaps a few feeble brown dwarfs, none of which cast significant light. The universe's tapestry, once bright with the glimmer of billions of suns, has become a sparse scattering of faint remnants. If any observer was still around, they would gaze up at a sky devoid of the familiar stars that once brought comfort and wonder. Only darkness, occasionally broken by the weak glow of a distant remnant or the rare burst of a collision, is left to reign. In this starless darkness, the worlds that once orbited those vanished suns are left to their own fates. Planetary systems, now without a central fire, either drift aimlessly through space or remain bound in cold orbit around the invisible cinders of their stars. These are the cosmic orphans, planets, moons, and other debris that have lost the lights that nurtured them. In the endless night that has now fallen, their story quietly continues. The tale of these wandering children of the cosmos adrift in the dark. With the last stars gone, a profound darkness has settled across the cosmos. Yet it is not entirely empty. Countless planets, moons, and fragments of former solar systems still remain, drifting through the black void. These worlds, once illuminated and warmed by their parent suns, are now cosmic orphans. They wander with no star to orbit, carrying on through perpetual night. Long before the final stars died out, many planets had already been cast off from their systems. Over billions and trillions of years, gravitational tugs from passing stars and stellar remnants gradually disrupted the stable orbits of planets. A close flyby between two ancient star systems could yank planets from their paths, flinging them into interstellar space. Some planets, especially those on the outskirts, were ejected entirely, while others closer in eventually spiraled into their dying suns or were engulfed during the tumultuous red giant phases of their stars. As a result, by around 1 quadrillion years into the future, 1,000,000 billion years, most planetary systems had unraveled. Virtually every planet was either thrown loose into the galaxy or had fallen inward to be consumed by its star's remnant. The Milky Way and all galaxies effectively let go of its worlds, scattering them like dandelion seeds into the dark. Now these free-floating planets roam the interstellar and even intergalactic void, solitary travellers in an almost starless expanse. Not every planet was immediately banished. A few clung on in orbit around the corpses of their stars, circling in darkness around an invisible white dwarf or a quiet neutron star. But without starlight, those planets were as cold and lightless as any rogue drifting in open space. Even these last-bound planets will, given enough time, either drift away or spiral into their dark suns, leaving no remaining solar systems intact. Imagine one such orphan planet, perhaps a world like Earth, drifting far from any sun. Without sunlight, its surface temperature has plummeted almost to absolute zero. Any atmosphere it once had has long since frozen and fallen to the ground as a layer of frost. If it had oceans, they are solid ice from the surface to the depths, frozen harder than stone. There are no days or seasons anymore, no winds or clouds. Even the air lies frozen as a solid sheet. Mountains and valleys are coated with eternal frost, and the only sounds are the creaking of ice as the planet slowly contracts in the deep cold. The entire planet is a silent, frozen globe, wandering through an eternal night. Overhead, the sky is utterly black. Not a single star breaks the darkness. The Milky Way's soft band is gone. All that remains above is a void. Now consider a different kind of orphan, a gas giant, like a lone Jupiter cast into the void. This enormous planet is cloaked in perpetual darkness. Its colourful cloud bands and raging storms still swirl in its atmosphere. But without a sun's rays, they are invisible, hidden in the black. Even the great storms that once raged across its face, like Jupiter's ancient red spot, still churn in ghostly silence. Without sunlight, such tempests are invisible, vast hurricanes whirling in the dark. Deep within, the gas giant might still generate a faint trickle of heat left from its formation, but that warmth barely reaches the tops of its clouds. From an outside perspective, that planet emits no visible light. It is a cold, dark sphere drifting endlessly. Some of these wandering planets carry moons on their journey. A large planet might retain a retinue of moons, little companions continuing to orbit around their planet in the dark. Together, they form a miniature, isolated system, bound by their mutual gravity, even as they drift far from any star. In some cases, the gravitational pull of a massive planet might continue to knead a moon's interior, driving volcanoes or geysers that glow faintly with internal heat. A moon could erupt with molten lava or jet out warm plumes, a final flicker of geologic activity in an otherwise lightless domain. In the absence of sunlight, the only illumination on such moons would be the faint light of distant stars or galaxies, now exceedingly dim, or perhaps the ghostly glow of the planet's own auroras driven by cosmic rays. The smaller remnants of solar systems travel as well. Asteroids and comets, once confined to orderly belts, now wander independently through space like everything else. In this darkness, a comet never grows the shining tail it would when near a sun. Its ices remain frozen solid, and it stays an invisible chunk of rock and ice. Now and then, two drifting asteroids might collide, or a lone moon might crash into a planet, releasing a brief burst of heat or a faint glow. But such events are rare and fleeting, quickly swallowed by the endless night. Most of the time, the dust, rocks, and ice of bygone worlds simply float quietly, never again forming new planets or feeding the fires of stars. Any life that might once have lived on these worlds has long since perished. Without the energy of starlight or any steady source of heat, ecosystems would collapse in the eternal winter. Perhaps in a few rare cases, Some organisms could survive by clinging to geothermal heat. Imagine microbes deep in an ocean under miles of ice, warmed by the planet's core. But even those refuges would eventually freeze solid as the planet's internal heat dissipated over the eons. For all intents and purposes, this dark cosmos is lifeless, a graveyard of frozen worlds under a sky that never brightens. In this profound darkness, no new stars will ever ignite. The era of cosmic birth has ended. No new fires are kindled in the void. What remains is the slow decay of whatever energy is left. The once active universe has become quiescent, with change now unfolding at an exceedingly slow, quiet pace. The universe has become like a boundless ocean of night, starless and still. Only the ceaseless pull of gravity and the final fate of the most massive objects offer any hint of events to come. Of all the objects still in existence, the most massive and enigmatic are the black holes. These invisible giants, left behind by collapsed stars and bygone galactic cores, still contain substantial mass and hold court over what matter remains nearby. They too are destined to change, but on timescales even more immense than everything that has come before. In the coming era of the universe, even these last titans will gradually fade away. The silence will deepen further as the cosmos approaches a final, ultimate darkness. The cosmic forge has gone cold, like a great hearth that has burned down to cold ashes. The once bright furnace of creation is now dark. In this final era, no new stars will ever spark to life. The creation of new galaxies and suns is forever in the past. The silence deepens further. This is a universe where no new fires are born, and the light of creation has permanently faded. All that remains now are the faint remnants of what once was. Black holes squat in the darkness, holding what mass is left from countless dead stars. Scattered around them are the cold, lightless cinders of those stars, black dwarf cores, neutron stars, and the frozen, wandering planets. If fundamental particles like protons eventually decay, then over incomprehensibly long times, even those last solid objects will dissolve into radiation, erasing the final traces of normal matter. One way or another, the cosmos is left with only ghostly forms of matter and an ever-thinning sea of energy. In the absence of any new light, the massive black holes become the dominant feature of the universe's landscape. They drift through the darkness, largely isolated now that everything else has either been flung away or fallen in. A supermassive black hole that once anchored a galaxy might sit quietly for eons, perhaps occasionally devouring a stray wandering object that comes too close. Such events are exceedingly rare by this epoch. Most black holes simply persist in silence, holding on to whatever matter still orbits them in the dark. Yet even black holes are not truly eternal. Over immensely long spans, they slowly lose mass via a process called Hawking radiation. This is a whisper-faint release of particles and energy that very gradually causes a black hole to evaporate. At present, and for trillions of years to come, this effect is negligible, far colder and fainter than even the residual glow of the Big Bang. But in the emptiness of the far future, it is the only new light being produced at all. The evaporation of a black hole is an almost absurdly slow process. A black hole with the mass of our Sun would take on the order of 10 to the power of 67 years to completely evaporate. A 1 followed by 67 zeros, a length of time beyond imagination. More massive black holes, such as those in galactic cores, live far longer still. A giant black hole weighing billions of suns might endure for 10 to the 100 years or more before it finally radiates away. By comparison, the current age of the universe, a mere 10 to the 10th or so years, is an eye blink. Smaller black holes will vanish first, one by one, in the extreme distant future. As eons pass, the population of black holes steadily dwindles, leaving only the titanic ones for last. In an unimaginably remote epoch, on the order of a Google, 10 to the 100 years, the very last great black hole will be nearing its end. It will shrink down over time, growing hotter and radiating faster as it does. When that final black hole eventually evaporates, it may go out with a quiet flash of energy. All of its mass, accumulated over eons, will be converted into a last burst of light and particles. For an instant, the eternal night will be punctuated by a brief glimmer, the final farewell of a black hole. After that, no heavy objects will remain. The universe will contain only diffuse, feeble radiation and elementary particles, fading into the void. At this point, the universe has reached a state of near-perfect equilibrium. What remains is a thin, cold mist of photons, light, neutrinos, and other subatomic particles, spread evenly across ever-expanding space. The temperature everywhere is almost absolute zero, with no gradients left to drive any process. This is the heat death of the universe. All sources of usable energy are spent, and the cosmos has settled into maximum entropy and stillness. In this profound darkness, time itself almost ceases to matter. With no events to mark the ages, billions upon billions of years slip by unnoticed, nothing distinguishing one epoch from the next. The universe is effectively dead, a vast, silent expanse where the once brilliant galaxies and stars have given way to an infinite, starless night. It is an eerie and solemn finale. The grand cosmic drama that began with the brilliance of the Big Bang ends in quiet and darkness. And yet, one might wonder, is this truly the absolute end? As far as we understand, it appears so. The universe has exhausted its fuel and slipped into eternal silence. Unless some new physics or cosmic miracle intervenes, a spontaneous rebirth, a random quantum fluctuation that sparks a new creation, the universe will remain in this dark, diffuse state forever. In all likelihood, the magnificent story that began in blazing light now concludes in infinite quiet and shadow. No new dawn will ever break this eternal night. In the unimaginable future, long after the last glimmer of starlight has faded, the universe lies in a deep and enduring calm. All the brilliant galaxies that once lit up the cosmos have gone dark, their fires extinguished, leaving only faint and ghostly remnants behind. What remains is a vast expanse of space, growing ever colder and quieter as eons pass without new light. This is a time beyond reckoning, when the vibrant era of stars and galaxies has given way to a profound and final equilibrium. Long ago, the cosmos was ablaze with starlight, but those days have irretrievably passed. The most massive suns burned through their fuel in mere millions of years, living brief and furious lives that ended in spectacular supernovae eons ago. Their catastrophic deaths left behind dense remnants, neutron stars and black holes, which linger as lightless memorials of those brilliant suns. Smaller, steadier stars, the red dwarfs that glowed gently for trillions of years, lasted far longer. But even they have finally exhausted their fuel and flickered out. One by one, in galaxy after galaxy, the stellar lights have winked out, until no new stars can be born, and the universe's grand illumination has faded away. Even the embers of those long-dead stars have finally gone dark. White dwarfs, The hot cores left behind by medium-sized stars glowed faintly for trillions of years as they slowly cooled. Eventually, they lost their remaining heat and became black dwarfs, cold, lightless spheres of carbon and oxygen, indistinguishable from the darkness of space. In essence, each became an enormous frozen crystal adrift in the void. One could imagine such a dead star as a giant diamond lost in an endless night. Neutron stars, the dense remnants of supernovae, once crackled with magnetic energy and emitted thin beams of radiation. But they too have fallen silent and frigid. The cosmic graveyard of stellar remnants lies cold and still. Each erstwhile star is now nothing more than a dark, inert cinder drifting through an endless night. Yet even in this era of darkness, there may have been the occasional flicker of defiant light. On extremely rare chances, two collapsed stellar remnants might drift into each other and merge, sparking a brief resurgence of starlight. Perhaps, in the midst of endless night, two cold white dwarfs collided and for a short time formed a new star, or a pair of dead stars combined to trigger one last supernova. Such events would have been like final fireworks in the darkness, brilliant but transient, scarcely delaying the inevitable eternal night that followed. With every source of light extinguished, the remaining warmth of the cosmos has seeped away into the abyss. The heat that once radiated from stars and galaxies has dispersed, spreading thinly across the vast emptiness. It is as if the universe were a great campfire that has burned down to its last embers. The warmth of those embers has drifted into the night, leaving the air all around just as cold. Over unfathomable spans of time, any regions that were once warmer have shared their heat with the cooler void, until all of space has reached a uniform, frigid temperature. In fact, the temperature across the universe now is barely a whisper above absolute zero, the coldest temperature nature allows. At absolute zero, all thermal motion ceases entirely, and nothing can be colder. The cosmos has nearly reached this extreme. Only the faintest remnant of warmth lingers, just enough to keep it from total zero. In this deep freeze, whatever particles remain move so sluggishly that for all practical purposes, the universe has fallen into an almost perfect stillness. Now, no corner of the universe is significantly warmer or colder than any other. Every faint particle and every drifting photon carries roughly the same tiny amount of energy as its neighbours. This is true thermal equilibrium at the grandest scale. The once dazzling temperature differences between stars and space have completely vanished. In this state of perfect balance, the universe has reached what physicists forewarned as the heat death, a final stillness where entropy is at its maximum and the cosmos has no free energy left to drive any change. It is the inevitable fulfillment of nature's tendency toward disorder. Over incomprehensible durations, all energy differences have evened out, exactly as the laws of thermodynamics foretold. Time itself carries little meaning in this silent era. Moments, years, and eons blend together when there are no changes to mark their passing. The arrow of time, once marked by the birth and death of stars and the growth of galaxies, has nearly lost its direction. It is as if the cosmic clock has unwound and come to a stop, its hands frozen in place. In a universe where nothing happens anymore, one moment is nearly identical to the next. If some conscious observer could survive into this deep future, they would find the experience eerily uneventful. Imagine drifting eternally in a lightless void where not a single new star will ever shine, nor a single new sound be heard. Our hypothetical traveller might wait millions or even billions of years, only to discover that nothing at all has changed. Without day or night, without seasons or any celestial motion, time would feel like a boundless ocean of darkness, a quiet that stretches on without end or variation. There is a profound, almost melancholic peace to this final cosmic night. All the turmoil and drama of earlier epochs, the fiery births and violent deaths of stars, the titanic collisions of galaxies, have long subsided. What remains is a calm that borders on absolute silence, an expanse of near-nothingness that is strangely serene. The universe rests in this darkness, as if in a deep slumber after an eternity of activity, an endless sleep from which there is no awakening in sight. It is an eternal midnight throughout the cosmos. No sunrise will ever break over any horizon, and no new dawn will ever come for the galaxies that once were. The cycles of day and night, of seasons and orbits that once defined time for worlds, are all memory now. Everywhere is the same starless darkness, and it will remain so for as far as time stretches ahead. This is the dusk that never becomes dawn, the final evening of the universe, everlasting and still. And yet, even in this seemingly absolute stillness, the story of the cosmos may not be completely over. For while no stars shine and no galaxies swirl, deeper down on the level of the very smallest pieces of matter, change may still lurk on unimaginable timescales. The fundamental building blocks of matter, protons and other subatomic particles, might not be truly immortal after all. Given enough eons, even these basic particles could begin to decay, heralding a new and final chapter in the long tale of cosmic evolution. In that remote era, even the notion of matter's permanence comes into question. For eons, atoms have endured, surviving the violent births of stars and the collisions of galaxies. But now, in the extreme stillness of the far future, those atoms themselves face a slow unraveling. According to some of our deepest theories of physics, protons, the tiny cores of atoms, are not truly eternal and can eventually decay, given a long enough timeline. The decay of a proton is an almost inconceivably slow and rare event. It is so rare, in fact, that not a single proton is known to have decayed in the entire 13.8 billion year history of our universe. Experiments have watched huge tanks of matter for years without seeing one fall apart, implying that a proton's lifetime must be staggeringly long, on the order of 10 to the 34th power years or more. That number is mind-boggling. It means a proton might last a trillion times longer than the universe has existed so far. Such is the timescale of its decay. Yet the universe has nothing but time, and over truly boundless ages, even the tiniest chances eventually come to pass. What is practically impossible in a mere billion years becomes all but certain, given enough trillions upon trillions of years. In the deep hush of this future, after uncountable eons, protons that once seemed indestructible do begin to falter and decay, one by one. It starts slowly, almost imperceptibly. Perhaps somewhere in the darkness, a lone proton inside an atom of drifting gas makes the transition. It disintegrates, releasing a tiny flash of energy and a spray of lighter, subatomic particles. Such an event is so faint and so rare that it passes with no fanfare, unnoticed in the vast emptiness. But it has happened. An atom has quietly died, its very identity erased as its proton heart vanishes. Over incomprehensible stretches of time, these once-in-a-blue-moon events become more common simply because eternity is relentless. Atom by atom, matter begins to dissolve. A piece of solid metal, a drifting asteroid, or a frozen planet. Every one of them is composed of trillions of protons, and eventually those protons start blinking out of existence one after another. To an outside observer, the object would seem to slowly evaporate into radiation, as its atoms decay into non-existence across ages that defy imagination. No structure, no matter how solid or dense, can escape this fate. The last grains of interstellar dust, the ancient frozen remains of long-dead planets, the cores of extinct stars, all of it will eventually disintegrate. A lonely, cold boulder drifting in space might seem eternal to any normal sense of time, but given enough eons, it will literally crumble away atom by atom. After trillions upon trillions of years, every rock and every speck of matter that once existed has resolved itself into a cloud of particles and faint energy, its solid form gone forever. We can imagine, for instance, a solitary planet that somehow survived the earlier eras, drifting lightless in the eternal night. For ages, it would remain intact, a silent testament to a bygone universe, its surface covered in the husks of extinct life, or the ruins of ancient geology. But as the eons stack into the unimaginable, even this forlorn world would not endure. Its mountains and iron core would slowly lose their substance, as proton after proton within them decays. In time, the planet would simply fade away, its material dissolving into faint radiation until there is nothing left of its once grand bulk. After an almost incomprehensible length of time, the ordinary matter of the universe will have all but vanished. The atoms and elements that once formed countless stars and worlds have been reduced to a thin gruel of radiation and elementary particles. And yet, even then, there remain the great sentinels of gravity, the black holes. These dark giants, formed from collapsed stars and central galactic cores, still contain mass, locking it away behind horizons from which not even light can escape. For now, they persist as the last massive structures in existence. To an observer of this age, these silent Goliaths would seem almost eternal, unaging sentinels in a universe that has otherwise faded to nothing. Black holes might appear eternal, but even they are slowly bleeding energy through a phenomenon known as Hawking radiation. In the darkness around a black hole's boundary, tiny quantum fluctuations constantly occur. Particle-antiparticle pairs flicker in and out of existence. Occasionally, one of these particles falls into the black hole while the other escapes, stealing away a minuscule amount of the hole's energy. To an external view, the black hole is very gradually evaporating, losing mass bit by bit in an almost imperceptible trickle of radiation. This evaporation process is extraordinarily slow. For a black hole as massive as a star, it would take many times the current age of the universe for it to noticeably shrink. For the titanic black holes once found in the centers of galaxies, some containing the mass of billions of suns, the evaporation time is almost beyond comprehension. It could be on the order of 10 to the power of 100 years or more. That's a 1 with 100 zeros after it, an expanse of time so vast that to call it astronomical is an understatement. Yet even that unfathomable epoch will eventually arrive, and one by one, these last dark behemoths will run out of mass to give. As a black hole nears its end, its decay accelerates. In its final moments, when it has shrunk to a critical size, it releases its remaining energy in a swift burst of light and particles. What was once an abyss, capable of swallowing stars, simply evaporates in a last brief blaze, like a candle flickering out. For a fleeting moment, the space around it is aglow with energy released from the black hole's grasp. A final, ghostly illumination in the dark. But an instant later, even that light fades, swallowed by the endless night once more. After that, nothing of the black hole remains. Its mass is returned to the universe as a final whisper of radiation, quickly dissipating into the cold. With the demise of the last black hole, the universe is left utterly bereft of heavy structures. Not a single atom or lump of matter remains. All of it has either decayed or been radiated away. What fills the cosmos now is a thin, almost ethereal soup of particles and radiation, dispersed across an ever-expanding emptiness. The transformation is complete. From a universe once rich with galaxies and starlight, we have arrived at a cosmos that is effectively an empty void, dusted only with the faint afterglow of all that has disintegrated. While matter and energy were undergoing these transformations, the fabric of space itself was not idle. Throughout the eons, the universe continued to expand, and in fact, this expansion accelerated, driven by a mysterious force we call dark energy. As space stretched faster and faster, it began to isolate every region of the cosmos from every other. There came a time when galaxies that had once been near neighbors were receding so rapidly that their light could no longer bridge the ever-growing gulf between them. For example, in the far future, our own Milky Way galaxy and its neighbors in the local group will coalesce into a single huge galaxy. That lone amalgam of stars will drift in an expanding void, with no other galaxies visible beyond it. By then, everything outside our small galactic island will have slipped over the cosmic horizon and vanished from sight. The inhabitants of that distant future galaxy would see nothing but an endless sea of blackness beyond their own stars. Eventually, a cosmological horizon formed around each collection of matter. This horizon is like a limit beyond which nothing can be seen or communicated, akin to an event horizon around a black hole, but on the scale of the entire universe. Any galaxy or light that lies beyond this horizon is forever unreachable, as the space between grows so quickly that even a beam of light cannot ever cross it. From the perspective of any given observer, the rest of the universe has effectively slipped out of view, hidden behind this veil of expanding space. Indeed, astronomers calculate that by around 150 billion years after the Big Bang, virtually every galaxy outside our immediate supercluster will have disappeared beyond this horizon, never to be seen again. One might picture the galaxies as boats on a vast ocean of space. In the early times, many boats were clustered nearby, their lights visible to one another across the dark waters. But as the ocean expands and time goes on, the boats drift further and further apart. Eventually, each boat is surrounded by nothing but empty sea in all directions. Its fellow travellers long since vanished below the horizon, never to be seen again. So it is with the universe in this distant epoch. Imagine an observer, perhaps on some remnant world or space station in a far, far future time. When they gaze out into the sky, they find a truly empty scene. No swirling galaxies or sparkling clusters mark the heavens. Only darkness in every direction. The stars of their own local galaxy might still glimmer faintly, but beyond that, There is an infinite void with nothing to see. All the clues that once spoke of a wider universe have been erased by time and expansion. Even the faint afterglow of the Big Bang, the cosmic microwave background, has redshifted into oblivion, stretched to wavelengths so long and diffuse that no instrument could ever detect it. Our future observer would have no way of knowing that other galaxies ever existed, or that the universe began in a hot, dense state. To them, it would appear that the dark, lonely patch of cosmos they inhabit is all there is, an island of whatever light remains, surrounded by endless night, with no origin story visible in the darkness. The universe, once a web of countless interconnected galaxies, has fractured into isolated pockets. Each remaining cluster of matter, or later, each patch of faint energy, is alone, like a lone figure in an empty landscape, unable to reach others. The cosmos has become a multitude of solitary domains that cannot communicate or even know of one another's existence. It is a lonely picture, a cosmos of countless separate horizons, each fading into darkness at its edges, each containing only silence beyond its own scant contents. In fact, the old poetic term for galaxies, island universes, becomes the literal reality in this late epoch. Any remaining galactic system is truly an island, self-contained and cut off by an ocean of expanding space. What lies beyond its horizon might as well not exist at all, for no information or light from outside ever reaches in. The universe has become an archipelago of isolated realms, each alone in the dark, with only its own fading stars or energy for company. The universe now is a place of pure, formless energy. Cosmologists call this final period the Dark Era, an apt name, for nearly all sources of light have long since been extinguished. With all matter gone, what remains is a faint bath of radiation and a few ghostly subatomic particles adrift in space. This final light is not the brilliant illumination of stars, but the diluted afterglow of all the events that ever happened. The last photons released by dying atoms in evaporating black holes, still journeying outward. Every ray of light that once shone, every piece of radiant energy ever emitted, now simply blends into an extremely cold, diffuse background across the cosmos. As the universe continues to expand, it stretches this remaining radiation to longer and longer wavelengths. Photons that once were energetic, perhaps born in the hot core of a star or in the final flash of a black hole, have lost almost all their vigor. A ray of light that might have been visible or ultraviolet in ages past is now reduced to an exceedingly low-frequency radio wave, stretched so wide that its crest-to-crest length could span entire galaxies. Each photon is like a tired traveller who has spent all its energy crossing the vast cosmos, arriving at its destination as barely more than a whisper of what it once was. At this stage, light itself has effectively been rendered invisible. The typical photon in the universe now has so little energy that it would not register on any conceivable detector. Its wavelength might be measured in light years, and its presence is more theoretical than tangible. The once bright cosmos has become a nearly lightless void. Though energy still pervades space, it is so feeble and thinly spread that it casts no illumination. The temperature of this radiation background is only a fraction of a degree above absolute zero, a final coda of cold after the long cooling of the universe. Alongside these fading photons drift other ghostly remnants of the earlier universe. Countless neutrinos, produced in the first seconds after the Big Bang, and in great stellar cataclysms, still roam the cosmos. They have been stretched and slowed by the expansion as well, and they rarely, if ever, interact with any matter now. There are also feeble gravitational waves, ripples in space-time left from ancient cosmic events, now so diluted and drawn out that they gently roll through the universe unnoticed. All these phenomena persist as faint echoes of a livelier time, present everywhere, yet effectively undetectable in their weakness. What remains of energy in the universe has no structure or pattern left to it. It does not gather into stars or beams or any organized form. It simply exists as a uniform haze. This diffused energy cannot clump or spark any new activity. It is far too spread out and weak. If somehow one of these photons were to encounter the ghost of matter, it would carry so little warmth that it could not heat even a mote of dust. In essence, energy has become background noise, a faint murmur that does nothing but slowly fade as space stretches ever onward. In the darkness of this late era, the universe is quiet and still, suffused with an almost imperceptible glow. It is a glow without form or feature. No stars, no rays, no shadows cast. One could say the cosmos still holds a memory of light, but that memory has stretched into anonymity. What little energy remains is so diluted that for all intents and purposes, the universe appears truly empty, a void where even light itself has lost its way. The universe has entered a state of profound stillness. All the grand forces of evolution and change have finally exhausted themselves. No further growth or decay is possible under the known laws of physics. The cosmos now simply is, vast and unchanging. Entropy now holds absolute dominion. The universe cannot become any more disordered or uniform than it has already become. This final state has been aptly called the Big Freeze, for the cosmos is indeed frozen in a cold, immutable stillness. This is the ultimate quietus, the long foretold end state where the engine of cosmic change has turned off forever. It is a finale, both serene and haunting. The universe began in a furious blaze of creation, a hot, bright flash that gave birth to everything. Now, after an almost incomprehensible journey through time, it ends not with a bang, but with an endless sigh of silence. In a sense, the cosmos has grown old and slipped into a final sleep. The once ceaseless drama of galaxies and stars has given way to an infinite, dreamless rest in the cold of space. The fires have all gone out, and what remains is the quiet afterglow of a life well lived on the grandest possible scale. If one could watch the entire life of the universe in a high-speed time-lapse, it would be an awe-inspiring and poignant sight. In the beginning, everything would glow brilliantly as galaxies form and countless stars are born in a blaze. Then, as the film speeds on, those lights would slowly wink out, galaxies dimming as their stars die off, one after another. Clusters of galaxies would recede and vanish into the distance as expansion takes over. The frames would grow darker with each passing eon, until at last nothing remains visible at all. Only a faint, static haze on the screen. And finally, not even that. Time stretches on, but it no longer brings change or novelty. Trillions of years, quadrillions of years, googles of years. No matter how far into the future you go, the scene stays the same. With no new events to distinguish one era from another, epochs blur together into an everlasting now. In this frozen tableau, the passage of 1,000,000 millennia is as inconsequential as a heartbeat. The arrow of time has effectively been broken, with no direction left to point. One might imagine the universe at this ultimate stage as a weary traveller finally coming to rest. All journeys, all stories, and all struggles are over. What remains is a kind of equilibrium that paradoxically feels almost peaceful in its absolute stillness. There is no more pain or striving, but also no joy or creation. Only a calm that has settled over everything, like a cosmic nightfall with no coming dawn. This final cosmos is utterly inhospitable to life or intelligence. All sources of usable energy have been depleted. No star will ever shine again to warm worlds, and no chemical reactions can proceed in the near absolute zero cold. If any beings or machines had somehow persisted into this era, they would face an impossible struggle for survival, finding no fuel or sustenance in the endless night. The spark of life, which once flickered in the warmth of starlight, has no haven here. It has been irrevocably extinguished by the cosmic deep freeze. In this twilight of the cosmos, evolution has reached its end. The sprawling saga from the Big Bang through the age of shining galaxies to the dimming embers of creation has concluded. No further chapters in the story of the universe will write themselves through natural processes. The book of cosmic history is, for all we can tell, complete. The curtain has fallen on the cosmic drama, leaving a vast stage bereft of actors and light. What remains is an empty, unchanging universe. The stillness of the infinite, extending forever. And yet, as absolute as this ending seems, one cannot help but wonder, is this truly the final fate of everything? An eternal, silent night with no new dawn? For now, the cosmos lies in quiet darkness, no motion, no light, only an endless stillness. Perhaps this is an everlasting conclusion, or perhaps, hidden in that infinite calm, lies the seed of another beginning. Only the silence of time will tell. In the silent depths of an endless night, the universe has grown still. Every star that once burned with brilliance has long since guttered out. The galaxies that gleamed against the darkness have faded and dissolved into faint whispers of radiation. Nothing moves in the cosmic sea. It is a vast expanse of nearly perfect emptiness and quiet. In this final era of the cosmos, there is no light left to mark the passing of time, only an eternal midnight stretching onward. Yet even in this profound stillness, something subtle persists. What appears to be nothingness is not truly nothing at all. The void between dead galaxies still carries the fabric of space and time, and within that fabric, a quiet murmur continues. If one could listen beyond silence, they might sense a gentle hum underlying the emptiness, a whisper from the very quantum nature of reality. It is the faintest of phenomena, nearly imperceptible, but it is there. In the vacuum of space, far from any star or atom, the stage is set for quantum fluctuations. These are the tiny, spontaneous flickers of existence that arise even when everything else is gone. According to the laws of quantum physics, emptiness is never truly empty. Even with all matter and energy spent, the vacuum still seethes with tiny ups and downs, momentary blips where particles and their antiparticles appear out of nothingness, and then vanish almost as quickly. This constant flickering is like a hidden heartbeat in the void. Picture the fabric of space at the smallest scale, where uncertainty reigns. Here, energy can briefly concentrate in one spot, creating a pair of virtual particles, a particle and its opposite twin, that spring into being for a fleeting moment. They rush apart, then collide and annihilate each other, returning their borrowed energy to the vacuum. These pairs are called virtual because they can never be observed directly. They exist too briefly. Yet they are a fundamental part of how reality works at the quantum level. Even in absolute darkness and cold, these ghostly particles dance briefly before fading, as if the vacuum itself can never remain perfectly still. This phenomenon can be thought of as the vacuum's own form of noise, a soft background whisper that persists no matter how empty space becomes. It is an echo of uncertainty, mandated by the Heisenberg principle, that says we can never pin down energy with absolute precision. At every point in space, no matter how desolate, there is a tiny uncertainty that gives room for these fluctuations. One moment, nothing. The next moment, a flicker of something. Then nothing again. The cosmos, even in its twilight of heat death, still carries this restless quality, as if reality refuses to settle into absolute silence. To our everyday senses, such fluctuations are completely insignificant. They carry only the tiniest fragments of energy and last for incomprehensibly brief instants. If you were floating alone in the darkness, you would not feel them or see them. Space would still seem empty. But on the microscopic level, this emptiness boils subtly with activity. It's as though the universe, even after everything else has perished, cannot help but quietly breathe. These quantum whispers hint that the void might hold secrets of its own. While all the grand structures of the universe have crumbled away, the very ground state of reality, the vacuum, remains vital and dynamic. It has been compared to a calm sea that, upon close inspection, is alive with gentle ripples. From far away, the cosmic ocean looks flat and featureless in this late age. Up close, one finds it quivering with these minuscule waves of possibility, rising and falling without end. This is the strange truth. What we call nothingness is really a canvas of potential. The quantum fields that permeate all of space are still present, like invisible threads stretching to infinity. They cannot be eliminated. They are part of the construction of the universe itself, and as long as those fields exist, they carry energy, however slight. This energy is the so-called zero-point energy, the lowest possible energy that even empty space contains. Zero-point energy means the cosmos always has some amount of vitality, a minimum breath that cannot be removed, a final ember that refuses to die out completely. In this way, nothing is deceptive. The emptiest space still holds this ghostly energy, and with it, the capacity for change, however rare or slow. The whispers of quantum fluctuation are the proof that even in death, the universe has not reached absolute zero in every sense. Something stirs at the smallest scale. It may be almost nothing, a hint, a phantom, but it is not truly nothing at all. The stage of the cosmic void is not an empty stage. It has background performers, subtle and fleeting as they are, continuing their quiet dance in the dark. These gentle flickers carry profound implications. They mean that the story of the cosmos might not be completely over, even though all stars have vanished and time stretches without visible events. In the delicate foam of quantum reality, there lies a possibility, remote yet real, that new things could still happen. It is as if, in the dead of a winter night, one notices a tiny spark glowing faintly in the ashes. In that spark resides a hope, or at least a question. Could this be the seed of something more? The vacuum's whisper hints that the curtain has not fully fallen. There might be a surprising encore yet to come. And so, in the silent aftermath of cosmic decay, we find a paradox. The closest thing to nothing still contains the whisper of something. It is a dreamlike hint that creation might stir again. The universe in its old age listens to these tiny fluctuations, each one a momentary deviation from perfect emptiness. They are the smallest of murmurs, but together they suggest that the void is pregnant with possibilities. In the next breath of our journey, we will follow these hints further, exploring whether these quantum whispers might gather strength, and whether from this near nothingness a new chapter of existence could one day be born. For now, such a new chapter of creation remains only a remote and speculative possibility. The vast majority of quantum fluctuations are inconceivably tiny and fleeting. They spark into being and fizzle out in an instant, like fireflies in a dark field that leave no lasting light behind. Space remains black and unchanged by their brief existence. And yet one cannot help but wonder, given enough time and the right conditions, could one of those little sparks ever grow into a flame? Could a random flicker in the void somehow blossom into something as grand as a new universe? In the emptiness after heat death, even the faintest chance has all the time in the world to play out. The universe now has eternity stretched out before it. Across such limitless time, events that are virtually impossible within any normal time frame might eventually occur. It's like shuffling a deck of cards endlessly. Sooner or later, by pure chance, one might draw a perfectly ordered sequence. In the same way, given forever, even a perfectly quiet universe might experience a moment of wild deviation, a strange and sudden spark of creation flaring up against all odds. One idea is that our current nothingness might be deceptive, because the vacuum of space could hold hidden energy poised for release. If our vacuum is not absolutely stable, if it's like supercooled water waiting to freeze, then a tiny nudge could trigger a dramatic change. Imagine a small region of space where a quantum fluctuation finds a lower energy state, a sort of true vacuum different from ours. In an instant, that region would become a bubble of new reality. Like a tiny crystal of ice forming in cool water, it would release latent energy. The bubble would begin to expand at fantastic speed, fueled by the energy of the phase transition. Inside that bubble, a burst of creation would unfold, essentially a new Big Bang, a new expanding universe born right inside the old. This newborn universe would be a baby cosmos budding off from its parent. As it formed, it might pinch itself off from our space entirely, growing its own space and time within. To an external observer, if any existed in the dark vastness, it might appear as a microscopic flash of light that quickly vanishes from view, or perhaps as a rapidly expanding sphere that soon outruns anything we could observe. But within that bubble, time would begin anew. What was a vacuum moments before would fill with a hot, dense rush of particles and radiation, expanding and cooling, just as our universe did long ago. Galaxies and stars could eventually take shape inside, following their own evolutionary path, utterly oblivious to the cold and empty expanse outside their bubble. Our old universe would continue towards oblivion, but the bubble would be a fresh spark of order and activity, a child universe carrying on the cosmic story. It's a mind-bending scenario, but it's grounded in principles of quantum physics and cosmology. In fact, some scientists think that this kind of universe-generating fluctuation might not be a one-time event. They propose that reality beyond our observable universe is constantly undergoing inflation, an endless proliferation of bubble universes, each bursting into existence with its own Big Bang. In this vision of eternal inflation, new universes are like buds on a never-ending cosmic tree, Even as one branch of the tree, like our universe, grows old and bare, new buds, new universes, are always blooming elsewhere. If that's true, then the birth of universes is not a miracle, but a regular occurrence on the grandest scale. However, within the confines of our own dying cosmos, such an event would be extraordinarily rare. The probabilities we're talking about are almost unimaginably small. But almost is not the same as never. Given infinite time, even events of vanishingly small probability can and will happen. We might try to express the waiting time for a spontaneous new Big Bang in the emptiness, but the number is so large it defies comprehension. Physicists have estimated figures like 10 to the power of 10 to the power of 50 years or more, a number with tens of trillions of zeros. It is a span of time so vast that it dwarfs any process or structure we can conceive. For practical purposes, it is eternity itself. Yet, it is not truly infinite, and that means even the most unlikely outcome will eventually occur. In the cosmic casino of an endless timeline, a jackpot is inevitable if one plays long enough. So in principle, after an almost interminable darkness, the impossible could become inevitable. Picture an empty patch of space that, by a rare coincidence, begins to simmer with energy instead of remaining calm. Perhaps out of the quiet vacuum, a tiny speck of high-energy fluctuation bubbles up. Most such specks collapse back into nothing, but this one finds a foothold. Instead of collapsing, it triggers that runaway expansion, a little bang that becomes big. A blazing newborn cosmos bursts forth where before there was only night. From the outside, there might be no fanfare at all. The bubble might slip away into its own realm or be hidden behind the veil of our cosmic horizon. But on the inside of that bubble universe, there would be light and heat, expansion and growth. The arrow of time reset to the beginning, entropy starting anew at low values, and the drama of creation playing out once more. To use a poetic image, after the long winter of universal death, a single wildflower could bloom in the snow. That lone flower wouldn't turn the entire winter into spring, but it would create a small sanctuary of life and colour amid the bleak landscape. In much the same way, a new universe springing from the void wouldn't undo the heat death of our own universe. It would simply carve out a fresh pocket of existence where order and life could thrive again. The old cosmos would remain cold and silent, but this offshoot would carry the flame of creation forward. This vision of renewal raises profound questions about cause and purpose. In this scenario, there is no divine hand or external agent igniting the new universe. The parent of the new cosmos is essentially randomness and quantum law, a moment of spontaneous order, born for no reason at all beyond the curious play of subatomic chance, could give rise to an entire reality. It's a humbling thought. Even without intention, without design, the fundamental rules of physics allow for something as intricate and magnificent as a universe to emerge from almost nothing. Order can spring from chaos unbidden, given enough time. Though it sounds like science fiction, nothing in physics outright forbids this kind of event. It sits at the edge of our understanding, at the intersection of quantum mechanics and cosmology, where our knowledge is still incomplete. But based on what we do know, a vacuum fluctuation-generated universe is not ruled out. The laws of nature seem to permit it, even if the odds are so remote that we would never expect to see it happen within any normal stretch of time. Still, in the eternity after heat death, the normal rules of probability start to bend, and what is effectively impossible in a billion years might become inevitable over a truly boundless expanse. One can't help but wonder what that new universe would be like. It might be governed by the same physical constants and forces as our own, essentially making it a twin of our universe's infancy. Or it might have different settings, perhaps different types of particles, or even different dimensions of space, if the fluctuation that created it pushes it down a different path of physics. It could be that our cosmos, in spawning a new one, passes on some of its genetic information, or it could be a completely fresh roll of the dice. Either way, that new universe would go through its own cosmic evolution. It would have a birth, it would age, and maybe it would eventually face its own end. In this sense, our universe could become the ancestor of another, linking generations in a grand cosmic family tree. Apart from bubble universes, some have imagined a more cyclic vision on the scale of one universe. What if the end of our cosmos somehow wrapped around to its beginning? Could the death of the universe lead directly to a new Big Bang? Not as a separate bubble, but as a reboot of the very same space. This idea touches on time itself, and whether it might be circular. It's a concept that has appeared in various cosmological models. Perhaps our universe might one day collapse and explode into a new universe. Or perhaps the far future emptiness might connect to the moment of creation in a way we don't yet understand. Even without a collapse, some theories suggest the remote future of an expanding universe could be mathematically equivalent to a new Big Bang under a different description. Such possibilities mean that even as we contemplate heat death, we keep alive the hope that it might not be the absolute full stop at the end of history. The universe's journey may not be a one-way trip to oblivion after all. This brings us to the nature of time and endings. How could time itself permit a rebirth of order? To delve into that, we must look at what becomes of time at the end of the universe, and how the arrow of time might be made to turn around or begin again. We now follow this thread into the mysteries of time's echo and the prospect of a cosmic cycle. Time is a river that has slowed to a crawl in the aftermath of heat death. With no events left to mark its passage, time itself seems to have lost its meaning in this quiet, changeless state. In a universe without change, 1 second is no different from 1,000,000 years. The arrow of time, the one-way direction from past to future, defined by things growing older, colder, and more disordered, has essentially flatlined. Yet hidden in the laws of physics is the potential for time's flow to be rekindled, for the river to find a new current. The question arises, could time circle back on itself, or spark a new beginning, even after reaching this stillness? To explore this, we must understand why time had a direction in the first place. In our universe's lively days, time's arrow was drawn by entropy. Things naturally went from ordered to disordered, from hot to cold, from organized stars to dispersed dust. That increase of entropy gave time a clear sense of direction. But once maximum entropy is achieved, once everything is as uniform and random as it can be, there's no more forward progress into disorder. At heat death, entropy can scarcely increase any further. In that state, the difference between forward and backward in time grows blurry, because the physical processes that define time's flow have halted. It's as though the cosmic clock has wound down completely. And yet, in the quantum realm, the fundamental laws don't prefer one direction of time over the other. The equations that govern particles work essentially the same, whether time runs forward or backward. At the deepest level, forward and backward in time are nearly interchangeable to physics. This suggests that the arrow of time we experience is not a basic requirement of the universe, but an emergent trend arising from the collective behavior of matter, moving from order to disorder. If somehow entropy in part of the universe were to decrease, it would locally reverse the arrow of time, or create a new arrow altogether. A spontaneous fluctuation that brings a pocket of the cosmos into a more ordered state would be like a small eddy in a still river, momentarily flowing opposite the main current. In a sea of chaos, even a little island of order would find time inside it moving differently, perhaps effectively resetting the clock for that region. In effect, that patch of the universe would have its own timeline, a kind of brief loop in the onward flow of time. Now, the odds of a significant entropy decrease happening by chance are astronomically low. The probability is so small that it borders on impossible in any ordinary sense. But given unlimited time, even the remotest chance can eventually play out. This is the strange promise that eternity brings. With infinite opportunities, even events of vanishing likelihood may come to pass. Imagine a scenario where, purely by random coincidence, particles in some vast region of the empty universe happen to clump and organize into an extraordinarily low entropy configuration. It would be as if a scrambled puzzle suddenly assembled itself into a clear picture. That region would abruptly find itself in a state reminiscent of the distant past, perhaps something akin to the dense, hot conditions of the early universe. In that moment, time in that pocket would have effectively looped back or started anew, because now there is a gradient of entropy again. In essence, that would be an echo of time, a fragment of the past appearing again in the far future. This concept is closely connected to the idea of Poincaré recurrence. That theorem tells us that a closed system, left to evolve long enough, will eventually return, arbitrarily, close to its initial state. If the universe, or perhaps the portion of it within a cosmic horizon, has a finite number of possible configurations, then after an almost inconceivable span of time, it could cycle back to a state very much like the one it started in. It wouldn't be a precise, hand-tuned repetition, but rather an eventual echo of the past. If our cosmos has any kind of recurrence like this, then heat death isn't truly final. It's a plateau before things begin again. After eons of stasis, a glimmer of the universe's youth could re-emerge, as if the cosmos briefly remembers what it was like to be young and full of energy. Another intriguing proposal looks at the end and the beginning as two sides of the same coin. Some theorists suggest that the ultimate future of an empty universe might connect to the dawn of a new one. If the cosmos becomes completely empty and uniform, nothing but a thin, cold haze of energy stretched across space, then the distinction between something incredibly large and something incredibly small might vanish. When there are no structures or points of reference left, size itself ceases to have meaning. An almost infinite, featureless expanse could then be physically equivalent to an ultra-compact state. In a mathematical sense, the far future of a spread-out universe could mirror the conditions of a Big Bang in a new universe. Under this idea, time is circular. The ultimate end of one cosmic epoch transforms into the beginning of the next. The heat death becomes not a tomb, but a womb, an empty cosmos, quietly readying itself for a new explosion of light and form. In this way, the clock of cosmic time might be wound back to zero. Throughout history, the concept of a cyclical universe has appeared in many forms, and modern cosmology hasn't entirely let go of it. Beyond quantum fluctuation scenarios, scientists have explored visions of an oscillating cosmos. In some models, the universe might one day stop expanding and fall back in on itself, crunching all matter and space together, only to rebound in another Big Bang. In others, multiple cycles occur through collisions or transformations in dimensions beyond our own, each cycle giving rise to a new universe with its own expansion. while current evidence points to an endless expansion rather than a turnaround. The allure of cosmic rebirth keeps these ideas alive. They remind us that the notion of time as a loop, of endings leading to new beginnings, has a deep grip on the human imagination. Perhaps it even has a foothold in reality itself. We cannot be certain. But the cyclical view offers a hopeful twist to the cosmic story. So if physics does allow, in some extraordinary way, for the rebirth of time and cosmos after heat death, we are left with profound questions. What would that mean for everything that came before? Would a new universe have any connection to the one that came prior? Or would it be entirely fresh, with no trace of us or our stars? These are daunting puzzles to ponder as we imagine a cosmic rebirth. When a phoenix rises from its ashes, some trace of the old life becomes part of the new. Likewise, one may wonder if any memory or information carries over when a universe is reborn. Does the new cycle inherit anything from the previous one, or is each iteration a blank slate? These questions lead us toward the idea of cosmic memory, the possibility that some imprint of our universe could survive even its demise, to echo in whatever comes after. Before our journey reaches its final act, we now turn to this idea of cosmic memory, the traces of pattern and information that might outlast everything else, even in a universe gone seemingly dark. In the darkness of a heat-dead universe, there still exist faint echoes of all that came before. The very fabric of space is filled with the ghosts of bygone light and energy. Every photon that ever shone from a star, every particle emitted in the universe's youth, still drifts through the void, stretched to longer and longer wavelengths, but never truly gone. The background glow from the Big Bang itself, once a blazing fireball, has thinned and cooled to near nothingness, yet it remains as a whisper of that primeval dawn. These are the cosmic memories, the lingering signals and remnants that testify that something was here, long after the sources have vanished. Even as the universe approaches its quietest state, the idea of information offers a kind of permanence. In physics, there is a powerful principle that information cannot be destroyed, only transformed. When a star burns out or a black hole evaporates, the detailed information about all that fell into it isn't lost forever. It's encoded in the subtle correlations of the particles and radiation that remain. Over unimaginable eons, all events that transpired leave some imprint, however faint, on the universe. The patterns of what once existed are woven into the fabric of reality, like delicate threads that persist in a faded tapestry. They may be scrambled beyond recognition, but they are there in principle, etched into the final field of particles that spread thinly across space. Consider that after all the stars and galaxies have disappeared, the cumulative light they emitted still wanders the cosmos. By the time of heat death, this light is incredibly dilute and faint, stretched by the expansion of the universe until its wavelength is enormous and its energy feeble. Yet if one could collect it all, one would have a record, however jumbled, of everything that ever shined. In a similar way, the gravitational waves from collisions of black holes and exploding stars continue to ripple outward. Though they grow weaker with distance and time, those ripples carry the story of dramatic events from ages past. The cosmos, in this sense, has a long memory. It remembers every gravitational disturbance, every flash of light, and every particle reaction, preserving them in the ever-expanding archive of space. By the epoch of heat death, this archive is almost indecipherable. The information is smeared out across an enormous volume, mixed into a nearly uniform soup of low-energy photons neutrinos, and other ghostly particles. No conceivable intelligence could piece together these fragments in practice. The signals are just too faint and too diffuse. And yet, the principle that nothing is truly erased means that the universe's past survives in spirit. The patterns of atoms and lives and galaxies are not gone without trace. They have dissolved into the wider pattern of the whole. In the quiet after the end, one could say the universe still retains everything that ever happened to it, encoded in a code so complex that it appears as random noise. This notion gains a curious twist when we consider the far future and endless time. Given enough time, some of those random-seeming bits of cosmic memory might spontaneously coalesce into something recognizable again. Just as a stray breeze might momentarily assemble scattered ashes into the shape of what burned, the ceaseless fluctuations of eternity could cause fragments of information to briefly form patterns of the past. Imagine that by sheer chance, particles in the vast emptiness arrange themselves into a familiar configuration. It could be as simple as a tiny dust cloud reflecting the pattern of an ancient constellation, or as unlikely as the atoms momentarily aligning into the form of a flower that once bloomed on a long-extinct planet. A more fantastical possibility is the emergence of a so-called Boltzmann brain, a self-aware entity created entirely by a freak fluctuation out of chaos. In the endless stretch of time, it's not utterly impossible that particles could randomly assemble into a working brain, complete with memories. Such a mind would awaken, however briefly, with a full life's worth of experiences and images of a world that no longer exists. Dreams of sunlight, of people, of history, all conjured from the void. It would be a disembodied memory of the universe itself, a last echo of consciousness appearing in a cosmos otherwise devoid of life. The idea is deeply strange and profoundly lonely. A single spark of awareness lighting up in the darkness, carrying within it an echo of things long gone, and then fading back into nothing. Yet, in a way, even this grim scenario underscores how pattern and information can persist and re-emerge unpredictably, even after everything else has dissolved. Beyond such extreme thought experiments, we can also consider the persistence of the universe's fundamental patterns, the laws of physics and constants of nature. These too are a kind of cosmic memory, a continuity that links what was with what might be. If a new universe were to be born from the old, perhaps it would inherit the same underlying rules, the same charges and forces, the same quantum fields, carrying forward a resemblance to its parent. In that sense, the memory of our universe might live on as the blueprint for the next, ensuring that certain patterns never die, but instead are reborn in each cosmic cycle. Ultimately, the idea of cosmic memory offers reassurance that the story of the universe is not entirely erased by time. The details of every life, planet, and galaxy are not utterly lost. They are diffused into the grand symphony of particles that remains. The patterns we knew are hidden, but they persist as part of the greater pattern. The cosmos, even in death, holds on to the faint outlines of all that it was. And if something of the old still exists, even as a faint echo, then something of the old might influence what comes after. Perhaps these lingering traces and memories, subtle as they are, could contribute to a cosmic awakening down the line. If there is ever to be a new chapter, a rebirth of stars or universes, it may arise not from absolute nothingness, but from the rich, though diffuse, legacy the previous universe left behind. In this way, the persistence of pattern and information hints that the cosmos has not truly forgotten itself, and that the seeds of a possible return might already be sown in the fabric of what remains. Let us now turn to that tantalizing possibility that from the deep slumber of a dying universe, there could one day come a new dawn, a speculative cosmic reawakening that makes the end not an ending, but a transformation. From the deepest silence, the possibility of return emerges like a soft dawn glow on the horizon of eternity. The notion that the cosmos could awaken again after its death has captivated thinkers for generations. Long before modern science, ancient cultures imagined time as a circle, days and seasons, births and deaths, all cycling endlessly. In Hindu cosmology, for instance, the universe is said to go through infinite cycles of creation, dissolution, and rebirth. This instinct to see a phoenix rising from cosmic ashes finds new life in today's theoretical physics. Could the universe itself experience something akin to reincarnation? Might the final darkness be a prelude to another genesis, repeating or reimagining the cosmos we know? Modern cosmologists have pondered scenarios of eternal return in various forms. One classical idea is the oscillating universe, an endless series of big bangs and big crunches. In that picture, our current expansion would one day halt and reverse into a collapsing big crunch, compressing all existence back to a singular point, only for that point to explode outward again. The universe would then be born anew, potentially with the same ingredients rearranged into different galaxies and stars. In such a cycle, the heat death would be avoided. Instead of petering out, the cosmos would crunch and rebound like a cosmic lung breathing in and out forever. While current evidence suggests this fate is unlikely for our universe, the idea itself is captivating. It envisions a cosmos with a second chance built into its very nature. In such a view, the universe never truly ends, but keeps renewing itself in a grand, endless oscillation. For scientists and dreamers alike, it is a poetic possibility to ponder. Even without a big crunch, other cyclic models offer imaginative paths to resurrection. Some theories in quantum gravity and string cosmology suggest that what we think of as the Big Bang might have been a big bounce, the result of a previous universe contracting and then bouncing into expansion. In these models, what we call the beginning was actually a transition, and what we call the end might similarly feed into another beginning. There are ideas involving higher dimensions where our universe's death triggers a new universe on a membrane elsewhere, or where two brain worlds collide to ignite a fresh Big Bang, repeating periodically. These concepts are speculative, sitting at the fringes of science, but they all rhyme with an ancient hope that the end is not truly the end. The possibility of a cosmic reawakening also arises from the multiverse perspective. If our universe is just one of many, then in the grand ensemble of universes, creation is always happening. New universes are born even as ours ages. In that sense, the cosmos as a whole, the multiverse, is eternally youthful, constantly renewing parts of itself. Our own universe's heat death would be a local event, not a final curtain on all of reality. Somewhere out there, in the timeless foam, new big bangs are ceaselessly igniting, new spacetimes inflating with potential. And conceivably, perhaps after an incomprehensible span, even our empty space might bud into one of those new universes, as we explored earlier. The grand view of eternal inflation assures that existence never runs out of steam entirely. It just shifts its stage from one universe to the next, in an everlasting cycle of expansion and genesis. It paints a picture of reality that never truly grows old, always cycling into fresh forms. There's also the eerie idea of a precise eternal return, the thought that given infinite time, the universe could replay itself in every detail. We touched on the Poincaré recurrence. If the universe has a finite set of possible states and infinite time, every configuration, including one identical to this moment, will occur again eventually. Imagine a future so distant that our entire cosmic history, down to you reading these words, happens once more by sheer chance. Then it could happen again and again, infinitely often, scattered across the gulfs of time like rare pearls on an endless string. This scenario is admittedly far-fetched and might not be physically realistic, but it's a haunting possibility. It would be a literal, eternal recurrence, where not just the universe in general, but each event and life repeats itself. In that dizzying vision, the cosmos is like a great novel that, given enough time, inevitably reprints itself word for word. It's a perspective that challenges our understanding of time and uniqueness at the deepest level. Whether in broad strokes or exact repeats, the idea of cosmic return transforms the narrative of the universe. Instead of a single arc that terminates in silence, the story becomes cyclical or self-renewing. It offers a kind of cosmic immortality, not for individual beings, but for patterns, for existence itself. The stars may die, but new stars will form, here or elsewhere, or in another cycle. The universe may grow cold, but new universes can be born, or the embers rekindled. This perspective imbues the end of everything with a hint of optimism. Beyond the curtain of finality, there might be something more. Of course, we must acknowledge that these are speculative ideas. Our best understanding still suggests a universe that will expand forever and fade into darkness. We do not yet have evidence that a cyclical rebirth or a parallel cosmos will save us from the long night. But the mere possibility changes how we think about the end. It replaces inevitable oblivion with an open question, a realm of imaginative wonder. Humans have always found ways to see renewal in the face of death, from the turning of seasons to myths of resurrection. In contemplating the death of the cosmos, we find ourselves doing the same on the grandest scale, seeking a ray of dawn after the longest night. In this spirit of curiosity and hope, the dream beyond decay becomes a compelling vision. Perhaps the universe moves in endless rhythms, and we are part of a pattern much larger than one brief era of stars. Perhaps, even after the last galaxy's light has flickered out, there is a spring waiting beyond the winter of space. It might take trillions upon trillions of years, or it might unfold in realms we cannot see, but the cycle could renew. The atoms that once made suns and living beings could be drawn together again to spark new light and life in some distant tomorrow, or in another world entirely. As we stand at the edge of time's horizon in our minds, peering into the cold twilight of the far future, we carry with us this thought: the final end may not be final at all. The universe has surprised us before. From the ashes of stars, new planets form. After destruction comes creation. So perhaps the ultimate fate will hold another surprise. The prospect of return invites us to accept that we simply do not yet know everything about existence. It keeps alive a glimmer of hope and curiosity, even when facing the absolute zero of being. Our journey through these cosmic endings leaves us not with despair, but with a profound sense of wonder. The silence after the final star may be a prelude rather than a finale. Instead of finality, we find a horizon still brimming with questions and possibilities. The stage may go dark for a time, but the cosmic theatre might yet prepare for another act, an encore hidden in the wings of eternity. In the end, or what we have been calling the end, there may yet be a new beginning. The ultimate fate of the universe remains a mystery, one that beckons us to imagine and to hope. After the last galaxy's light has faded away, something unseen could stir in the darkness. In that quiet beyond the end, we might envision not a cold full stop, but the soft turning of a page. Perhaps, against all odds, the first faint glow of a new cosmic dawn will quietly emerge, telling us that the story of existence is not over after all. The Earth is but a single, quiet note in the grand cosmic symphony. In the silence of the night, we stand beneath a tapestry of stars and feel a mix of awe and humility. Each star that twinkles above us is an ancient beacon, its light travelling across unimaginable distances and eons before reaching our eyes. We are extraordinarily fortunate to exist in a time when such light still graces our skies. Our brief era is a fleeting moment compared to the age of the cosmos. We find ourselves in what astronomers call the stelliferous era, the age of shining stars, which itself is only a brief interval before the universe grows dim. Simply by being alive now, we inhabit a rare and precious time, a gilded age of light that will not last forever. Out here on our little blue world, every sunrise and sunset reminds us of our place in the universe. Each morning, sunlight warms our faces and brings life to the day. Each evening, the sky's fading light draws a curtain across the heavens. These rhythms of day and night echo larger cosmic cycles, reinforcing how transitory our daily lives are in the long march of time. Yet in those golden hours, when the sky glows with warmth, we often feel a sense of wonder that transcends our mundane concerns. Every sunrise and sunset is a gift, a moment of beauty that we eagerly embrace and then let slip away, just as every civilization on Earth has cherished its own bright moments before passing into history. In the quiet darkness that follows each sunset, we remember that our days are numbered, but each one is special. When we gaze upward on a clear night, we catch a glimpse of this vast history. Some of the starlight we see tonight was born before Earth existed. Those stars may already be gone, but their light sails on. We are, in effect, looking into the past with each glance at the sky. This cosmic time travel reminds us that we inhabit the present built on memory. Each constellation and nebula carries within it the record of what once was. And so our understanding of the universe is, in a sense, a mosaic of memories and light from ages long gone. Standing on Earth, receiving that ancient light, we are poignantly aware of our own fleeting tenure on this grand stage. We feel connected to all that came before, and we wonder how long our own light will burn. Remarkably, we humans are the first known creatures to contemplate the fate of the universe itself. We have built telescopes and turned our inquisitive gaze toward the heavens, piecing together the cosmic story through mathematics and observation. Our knowledge of physics tells us that the lights of stars will eventually die out one by one, like lamps gently switched off until none remain. In our hearts, however, we feel more than equations. We feel awe, gratitude, and even a touch of sadness at our tiny role in the saga. Yet within that humility lies strength. We find a deeper reason to cherish each fleeting day. As we contemplate the coming darkness among the stars, our thoughts turn inward to another light, the fragile, warm glow of life itself. Right here on Earth, that warm glow is all around us. Every sunrise bathes the world in gentle heat that stirs life into motion, and every sunset coddles us in a cozy twilight. The forests and fields are filled with a quiet vibrance under the morning sun, and even in the coldest places, living things find ingenious ways to keep a flame alive within. From the tiniest seed to the tallest tree, each one is a kind of life flame flickering softly in the cosmic night. Even in our own bodies, light from the sun is captured by leaves and turned into the energy that fuels growth and warmth. The sun's rays today warm the air we breathe and strengthen the cells in our bodies, sustaining the flame of life in all its forms. This warmth is precious to us in every human experience. We gather around campfires and fireplaces. We light candles in windows, and even a single flickering flame can bring people together. We remember how comforting it is to huddle close during a winter's night, sharing stories by the hearth. These simple rituals echo our deep connection to light and heat. They remind us how vital warmth is, both in our bodies and in our hearts. In the soft glow of candlelight or the gentle crackle of a fireplace, families and friends draw close and find a sense of peace and belonging. A flickering flame can seem alive, casting dancing shadows and carrying a quiet magic that makes the darkness seem less daunting. Look at the natural world around us. An impermanence is everywhere. A flower that blooms in the morning often withers by dusk, its brilliant petals becoming a memory overnight. We cherish sunsets and rainbows because they are fleeting. Each dawn is unique, each spring, every blossom, each lifetime, a precious story that is sure to conclude. Our world teaches us this truth in subtle ways. The dew that sparkles at dawn evaporates by noon, and an autumn leaf's fiery colour soon fades and falls. Paradoxically, the knowledge that these moments will vanish only makes them more precious. It is as if nature itself turns vanishing into beauty. Knowing that every sunrise is one we will never see again, the same way inspires us to fully feel the warmth on our faces and to watch it closely. In that way, each bit of transient beauty becomes a little miracle to be treasured. Even as we bask in these warm and living moments, we are conscious of their fragility. Each creature on earth holds its own delicate flame of existence. From a firefly's brief flicker in the night to a whale's spout in the ocean, life blazes brilliantly, even if only for a short time. Every heartbeat and every breath fans that flame, giving it strength and purpose. Yet inevitably, each life will dim and extinguish. Each living being will one day return to stardust. This cycle of life and death on Earth is poignant, beautiful, and universal. To burn warmly and live richly for a time is itself a miracle. During its brief flame, a life can touch others, passing love and knowledge like a spark passed from hand to hand in the dark, so that the warmth continues even after one life ends. In this way, even an ember, like a single life, contributes to the long, gentle blaze of life on our planet. Humanity as a whole also carries a flame. Our entire civilization is like a campfire set up in the vast darkness. Empires and nations rise on its strength, giving light and warmth to their people. And yet, as history shows, these flames wax and wane. Great cities that once blazed with activity have become quiet ruins. Still, each fire once gave hope and light to countless lives. even as each chapter of history cools down. The sparks of culture and knowledge pass on. When one civilization fades, the next one catches fire anew, sometimes rekindling old wisdom or kindling entirely new light. In this endless relay, the flame of human curiosity and spirit continues. Civilization's lamp may flicker through ages, but the glow of our collective endeavor survives in the stories we tell and the understanding we share. Each fallen ember of history leaves a spark that ignites new creativity in others. In quiet moments, we recognize something profoundly poetic. The universe itself might be looking back at itself through our eyes. We are, in a way, its questioning breath, awake and aware in an enormous, silent expanse. As the cosmos drifts toward its future quiet, our curiosity adds a rare flicker of reflection to its stillness. For a brief time, the universe contains within it a spark of understanding and wonder. We carry the question of the cosmos's fate in our hearts, and in doing so, we give it purpose. Our minds and spirits have become part of the universe's story. In this perspective, the end of all things becomes not just a cold endpoint, but a moment of profound connection. We find ourselves gazing up at the stars and realizing that, for now, the story includes us. Thinkers made of stardust, pondering the final chapter of the stars. There is a quiet nobility in that realization. Perhaps it even feels a bit absurd that we pour meaning into a flicker of a flame. But as humans, we have always done so. We are like curious travelers in the vast darkness. Our lamps are small, and our journey is short. Yet we proceed with wonder and courage. We carry our candle of consciousness bravely into the night. Around every campfire and in every quiet room, we share stories and imagine the future, even as the evening grows late. In our tradition of exploring and learning, we light one small flame after another, knowing each will burn out, but still valuing its warmth. There is something gently defiant about that. Knowing the lights will dim, yet we kindle more light anyway. Our determination and courage ensure that our brief age of light shines as brightly as it can, even while preparing for the darkness that lies ahead. This is the human spirit. Fragile, warm, and unfaltering in the long dark. Even in a universe that will one day be dark, our own light carries meaning and hope. Though we are small, we have found ways to leave tiny trails of light behind. Our voices cross the void in radio waves, extending outward from Earth like ripples in a pond. Spacecraft drift away carrying human recordings and dreams, each one a small bottle cast into the cosmic ocean. These emissaries are like little lanterns we send out into the night, pieces of our knowledge and culture flying away faster than planets move. We know that eventually, even those faint signals will fade into oblivion. But for now, they demonstrate our spark reaching out. At least for a little while, even our inventions and signals carry a fragment of our life flame into the darkness beyond our sun. Remarkably, we are witness to all of this. We live at the very end of a long day for the universe. In the grand history of cosmos, the first stars blazed hundreds of millions of years before the Earth formed. Then galaxies thrived and faded. It was only in the final moments of that cosmic age that we opened our eyes. Think of cosmic history as a 24-hour day. The universe's dawn happened billions of years before sunrise on Earth. By the time our star was born and our world took shape, the day was nearly over. We show up just in time to see the last twilight, a flicker of the grand fireworks that will eventually fade tonight. The fact that we came into being now, when the universe is already so old and headed toward darkness, is both humbling and extraordinary. We feel privileged, like early morning stargazers seeing dawn's first light. In all this, every bit of light we see feels especially precious. To stand on this small planet and look out at the cosmos is to feel connected to everything that ever lived and will live. Each twinkling star is a reminder that light can travel, beauty can be carried, and stories can endure. We realize that our own journey is one brief, luminous chapter in a vast, silent book. Even so, this chapter is filled with wonder, with warmth, and with meaning. We carry our little flame together, our love, our science, our stories, shining against the cold. It will flicker and fade as all things do, but for as long as it burns, it will add its glow to the universe's endless night. And in that shared light, we find something quietly profound. Our own bodies hold this flame too. Every heartbeat is a little burst of warmth, fueled by the very atoms forged in stars long gone. In that sense, we literally carry the stars inside us, their energy turned into blood heat and breath. With each step we take, each word we speak, we manifest a living fragment of that ancestral light. We may be a momentary spark on a single world, but we connect the cosmos to itself. We smile, we cry, we wonder, all of it a way for the universe to experience its own beauty once more. Our conscious reflections are like the universe pondering itself. So when we gaze at the heavens, we see not only distant pasts, but also a piece of ourselves. The end of the cosmos, then, is also a gentle exhale of all the light that helped bring us here. And as we look inward, the fragile, warm glow of life on Earth becomes a kind of treasure. It illuminates our homes in the dark, kindles our dreams, and sustains us in the cold of space. It makes us brave enough to raise the questions that burn in our hearts. We gather around that inner light, united as humanity, and we ask softly, what comes after even this flame is gone? The thought may seem vast and lonely, but here around our shared fire, we find courage and calm. We understand that even as the universe's final page turns, the warmth we kindled by loving and learning will be what carries us forward in memory. In this gentle glow we remain, contemplating the mystery of what lies beyond the last star's dying light. The story continues in our reflections. Even as shadows fall on the cosmic stage, we hold another source of warmth close, the bonds we forge and the moments we cherish. In tenderness and in wonder, we nurture our own light. And so, without fear and with quiet wonder, we continue our narrative beneath these stars, mindful of their ending, yet comforted by the light we share in the meantime. Part 6 of this documentary has taken us into our own hearts under the night sky, and we will carry its lessons onward as the story gently unfolds into the final breaths of the cosmos and beyond.